Yeah, my name's Nathan Hendren. Today we're going to talk about neighborhoods, intergenerational mobility, and opportunity in the United States. The broad motivation for what I want to talk about is a large literature in social science talking about geographic variation in outcomes for both adults and kids across areas in the US and abroad. And the basic question we're going to go after is, to what extent does this variation suggest that there's a causal role that place has in shaping economic outcomes? And the key issue that we're going to grapple with for the course of the next 3 hours is, to what extent does these patterns represent one of two forces? On the one hand, variation in outcomes across areas could reflect the sorting of different types of people to different places. On the other hand, geographic variation in outcomes could be reflecting the causal effect that those geographies or those places are having on people's outcomes. And so separating these two distinctions is going to be the primary goal of the morning. And to do this, we're going to be focusing primarily on impacts on kids. I'll talk a little bit about adults towards the end of the talk. So just to structure things a little bit, in the first part of the talk, which is going to be probably a majority of the time, we're going to follow some work that I have with Raj Chetty that's going to first document geographic variation in intergenerational mobility across the United States. And then we're going to try to separate these causal versus sorting stories as an explanation for that variation using cross-area movers. Put specifically, kids who spend different amounts of their childhood in different places, and use that to try to learn something about this role of sorting versus causal effects. In the second part, we'll talk a little bit about what this might mean for thinking about economic policy. So we'll talk about two types of policies. Once you think place matters, then there's sort of two things you can do. You can change places, or you can change where people are. You can change the allocation of people to places. And so the first of those is generally referred to as place-based policies. So we'll talk about work in economics that has documented the impact of various place-based policies. So I'll walk you through some work that Roland and Will Dobby have on documenting the impact of the Harlem Children's Zone in New York. We'll also talk about choice-based policies, so changing the allocation of people to places, where here we'll look at both some work by, recent work by Eric Chin, looking at the Hope 6 demolitions in Chicago, which is added to here. I figured Chicago would be a fun place to talk about that. But then we'll also talk about the Moving to Opportunity experiment, which was an experiment that gave families the opportunity to move to different neighborhoods using Section 8 housing vouchers. Okay. So that's sort of the broad roadmap for where we're going to go. At some point, we'll find room for a break, hopefully. And so I'm anticipating that there'll be somewhere of a natural spot about halfway through. We'll take a little bit of a break. But as we go, feel free to pepper with questions, and we can make this an open discussion. I have plenty of slides to talk for 3 hours or whatever, but I'm guessing that wouldn't be as much of a good time for you as it, well, it wouldn't be a good time for me either, but feel free to ask questions as we go. All right, so I want to begin by trying to think through the geographic variation in mobility and to what extent this reflects the causal effects versus sorting of people to different places. And just going to begin by just documenting this variation in intergenerational mobility across the United States. And so what we're going to do is we're going to use data from de-identified tax returns from 1996 to 2012, where we're going to link kids to parents using dependent claiming. So there's this really nice thing in the US where when you file your taxes, you get a tax credit if you have kids. The way you do that is you list the social security number of your child on the tax form. That provides a link between the parent who is filing the tax form and the child. And so you can then use that link to match parents to kids to understand the parental backgrounds of different kids in a sample. We're then going to focus on children in the 1980 to 1993 birth cohorts, who we link then to their parents when the data starts in 1996 through that dependent claiming pattern. And so this is going to be about 50 million kids, including myself and I guess some people in this room as well. So the variable definition, so we're going to talk about intergenerational mobility, and when we do that, we're really kind of talking about the relationship between parent income and kid income. So we have to define parent income, and we have to define kid income. So for parent income, we're going to think of mean pre-tax household income averaged over 5 years from 1996 to 2000. For people that file, say, a 1040, which is an income tax return that you file in the US, that's going to just have that income directly on it. Not everybody in the US files an income tax return. That's for many reasons. For example, you might not have sufficient income for tax liability, or you might be evading taxes, for example. But for people that don't file, we also have information from what's called information returns. So if you've worked at a job and you get a W-2 form, so that's a form that you receive at the end of the year, but that's also sent in to the tax folks to mention how much income you had, and so we can use that information for people that aren't filing. Now we're going to look at different outcomes for the kids at different stages of their life cycle. So we'll talk about incomes at age 30 and their 20s. We'll talk about other outcomes like college attendance for kids, and think about kind of different outcomes at different stages of their life cycle. One of the things that we're going to do that's going to be useful for kind of reducing the dimensionality of the data is to focus on percentile ranks in the national income distribution. So when I talk about this, just to be clear about what we're going to be doing, when I talk about a child's income rank, I'm going to imagine taking everybody born in a specific birth cohort. So I was born in 1982. We'll take my income that I have, say, in a given year, and we'll rank that relative to everybody else who was born in the US in 1982. And we'll say, where 0 to 100 do I fall in that distribution? That would be the definition of my income rank. And so when I say child's income rank, that's what I mean. Now for parents, we're going to do a similar thing where we're going to take let me just define the parents' income rank. I'll come right back to you. For parents, we're going to define them in their specific cohort. So take my parents and take everybody else's parents in the 1982 cohort, rank them 0 to 100. And that's going to be the parents' income rank. Yeah?
What's the justification for using pre-tax household instead of post-tax?
Yeah, exactly. Great question. So people have focused on both, and you can do both, and they're similar. The way you want to think about it is sort of what's the question you're after, right? With pre-tax income, we think we're getting something closer to kind of what is kind of thought of as productivity measures, right? So it's before taxes. You can think of this as what might be equated to the marginal product of labor. And so in the intergenerational mobility literature, starting with Solon and others, they've generally focused on pre-tax measures of income. But a separate question is sort of what is the kind of actual take-home income and sort of welfare transmission across periods. Now that's a difficult question because even if you do post-tax income, you're not actually getting to consumption, which if you're doing welfare, you might want to do consumption. And then it gets very difficult when you start to think about intergenerational transfers across parents and kids. So actually Casey Mulligan, might have been his thesis, was focused on trying to measure consumption, or at least some of his early work here at Chicago was actually trying to think about what can we learn from patterns of income for what it might mean for patterns of consumption. Turns out to be a little bit harder of a question. Yeah. Other question? All right. Okay, so that's income. We're also going to talk about geography. So to talk about geography or neighborhoods, we have to have some notion of what we mean by these. The way we're going to conceptualize notions of neighborhood effects is to think of neighborhood effects as the sum of different geographic effects. So if you think that it matters what neighborhood you grow up in, then you can write the effect of a neighborhood as the sum of, say, your commuting zone, so like the broader Chicago metropolitan area, plus an effect of maybe what county you're in. So maybe it's Cook County, you're in the city of Chicago, plus maybe the effect of your zip code. Maybe you're in 60637, plus the effect of the block. So maybe you're at 57th and Kimbark, for example. Now all those you can think of as having a separate component where each of them kind of has mean zero within. You just kind of think about this kind of telescoping thing of overlapping these different levels of effects. For most of what I'm going to talk about, we're going to start at the level of the commuting zone, which we're going to call kind of neighborhood effects, not because we think that commuting zones are neighborhoods, but rather if you think of the variation across places at the commuting zone level, that's going to be a lower bound for the variation that you would see across local area neighborhoods. We'll also do some work at the county level as well. So commuting zones, I'll show you pictures of these in a second, but these are aggregations of about 5 counties or so. So if you know the Chicago area here, this is including DuPage County. It's including kind of the borders of Chicago. If you know Boston, it includes all of Cape Cod. So it's a big geographic area. Okay, so let's start off with just a geographic description of what intergenerational mobility looks like across areas. And so what we're going to do here is just focus on people. So stepping back, eventually we're going to want to try to decompose the variation in intergenerational mobility into a sorting and causal component. What we want to do to start is forget about movers, which we're going to use to kind of do that decomposition, and start with people who spend their entire lives growing up in a particular neighborhood. And so we're going to call these people permanent residents. So we're going to define permanent residents of a commuting zone as people whose parents stay in the commuting zone throughout our sample period. Okay? So think of it as people whose just parents, they start off in a given place and they stay there while you're growing up. Now, the kids, importantly, we're going to let move, right? So, for example, I'm going to show you some results for rural Iowa. A lot of the kids whose parents are permanent residents in rural Iowa might grow up to move to Chicago. We're still going to assign them back to the geography of where their parents were permanent residents, right? Okay. And so now what we're going to do is, given this kind of definition of assigning each person to this geography and focusing on this subset of permanent residents, we want to characterize the relationship between parent and child income in each of these different places. So to do this, what I want to do is just imagine taking each parent's income rank and putting it along the horizontal axis, and then asking for each level of parent income rank, what is the average child income rank? Now we could do this on aggregate, but actually what I want to do is focus on particular geographies. So what this graph is showing you is taking everybody who was born in 1985, whose parents are permanent residents of the Chicago commuting zone. Okay, so this is basically anybody born in 1985 whose parents stayed in Chicago in the sample. And this is ranking those parents in that sample from the poorest parent to the richest parent, where this is in the national income distribution of parents in that 1985 cohort. And so what you can see is that at the bottom of the income distribution, if you're born to a parent who's kind of the poorest parent in the sample, on average those kids grow up to be at about the 33rd percentile in the national income distribution. Conversely, if you're born to a family at the top of the income distribution, on average you're going to be at about the 63rd, 65th percentile, 62nd percentile of the income distribution. Now what's nice about this rank transformation of the data by focusing on this rank on the horizontal axis is that it generates this linearity in the pattern. And so this just is largely convenient because we can summarize the relationship between parent and child income just using two numbers. What are those numbers? We've got an intercept, right? Sorry, you had a question.
Is there a distribution that would give you that linearity? Like a multivariate distribution where you predict the rank slope to be exactly linear?
Oh, there's a huge class of distributions. So in fact, you can there's a non-parametric model that'll generate this. If you think that with some fraction, some probability, your income rank is equal to your parents' income rank, and with some other probability, your income rank is purely random, that would generate linearity. And so that's one model that'll do it. And then the degree to which you're off the 45-degree line is the fraction of people that are random. So actually, it's a broad class of distributions could get you the linearity, but the flip side of that is it's still, I think, quite striking that you do end up getting the linearity, and it's something that we've kind of grappled with and wouldn't say that we know for sure why. Yeah.
Multivariate normal wouldn't give you that, right? Just bivariate. I mean, I guess independence would. It's a special case.
So what matters is how the joint distribution. So I believe you can rationalize. So to the model I said, you could have any distribution of let's see, multivariate normal. No, so this is, so the distribution of parent and kid income ranks is not multivariate normal. So if you want to try to fit a normal-ish model to it, what you want to do is take logs and do a virtual income model, add about $25,000 to both the parents and kids. And then so if you take your income, add $25,000, take your parents' income, add $25,000, take logs to both of those, it turns out that's approximately jointly normal. You can thank Pat Klein for that finding, actually. But it's, the linearity is, it's not it doesn't have to be linear, it just turns out. And in some, cases, I'll show you some where it looks like there's a little bit of a deviation from linearity here and a deviation down from linearity here. That's actually, you actually can reject linearity on these things, but it's pretty close. Yeah?
I have a quick question about what this graph is saying us. So I look at this picture and it tells me that if you're poor, you stay poor, right? Is that the story?
If you're at the bottom of the income distribution, if your parents are at the bottom of the income distribution, on average, you're going to fall at the 30th percentile of the income distribution. Now, it's not deterministic. There's a distribution of kid ranks around each level of parent income, but the average is 30.
So there's no intergenerational ability.
I don't know. What do you mean?
I mean, if you were born, I'm just using simple numbers. If
Yeah.
your parents are poor, you're more likely to stay poor. That's what this
You have lower outcomes if your parents are poor than if your parents are high, but you also have regression to the mean. So for example, if you're born to the bottom of the income distribution, on average, you're going to earn more than your parents. If you're born to the top of the income distribution, on average, you're going to earn less than your parents, is sort of one way to interpret the pattern. But it is, certainly, the positive slope is suggesting intergenerational persistence. Absolutely. Cool. Yeah?
Is this accounting for the fact that they are kids, so there is a life cycle in the kids?
Good. So this is measuring kids' incomes at age 26, and I didn't even read this in the title. And so it turns out that another advantage of the rank transformation is that it stabilizes at younger ages relative to levels of income. So one of the things we've shown in some of the earlier work is once you get to about 26 to 30, after age 30 is really where it settles down, the ranks, the relationship between parent and kid ranks starts to stabilize as you increase the child's age towards 40 to 45. And so the way to think about that is that a kid at the top of the income distribution is on a different growth path. Their earnings are increasing dramatically throughout the 30s. But the way in which those earnings change relative to your peers is uncorrelated with parental income after age 30. So you still have income volatility after age 30, but that income volatility is no longer correlated with parent income once you've conditioned on where you are at age 30. That makes sense. That makes sense? Anybody? Okay, cool. Other questions? Cool. Okay, so this is showing you just for Chicago the linear pattern here. And what's nice about this linear pattern is that we can summarize the distribution of kid and parent ranks with two numbers. An intercept, right here, so we can just call this y bar 0 of Chicago for the 1985 cohort, which is the expected child rank for a parent at the bottom of the income distribution for that cohort. We can also form a prediction for what you would expect a permanent resident child outcome to be for any given level of parent income rank by just taking that intercept and adding in the parent's parental income rank times the slope of this line, right? And so that just gives us, in two numbers, a way of summarizing this pattern, which we're going to use now to look at not only Chicago, but also every place, every other commuting zone in the US. Yeah?
You said you reject linearity.
What's that?
I think you just said you reject linearity.
Absolutely.
And so when you're using these, but you're using the linear prediction.
Absolutely. So why is that, right? So this is the beauty of this is why with big data, frequentist statistics is pretty meaningless, right? You know, you can reject this line, this point is significantly different. You know, these are all significantly different from the line, but that's, you know, at the end of the day, if you get enough data, if you have a large enough n, you're always going to get p-values that converge to 0. What we want is a prediction that in practice is going to be really close to what we actually think is right. And so with the linearity model, we're going to get a prediction that is, you know, maybe going to be off a little bit, and you might even be able to statistically say that you're off by a little bit. But from an economic standpoint, it's going to be pretty meaningless, right? Because the deviations are not all that.
So it's not where it's trying to fit a polynomial.
So you could, yeah. So one of the things we do in the paper is show that if you do a polynomial, you don't get different results, even though the coefficient on the polynomial is statistically significant. Is another way of saying what I was saying before. Yeah. Yeah.
How this figure looks when you compare now with respect to the distribution of the national distribution of the Chicago distribution of income?
Ah, yes, good. So if you use local income ranks versus national income ranks. Turns out, and I'll maybe walk through this a little bit later, but turns out that you get very similar patterns. And so let me come back to that in just one slide, because I'll tell you in what sense I mean you get similar patterns, because you know, I haven't defined sort of what does it mean to even do anything local, because then you would just mechanically get everything to have the uniform distribution across the axis. But for a second, let me just now expand beyond Chicago and show you what this pattern looks like for every commuting zone in the US. So to do that, I need to pick a point along the horizontal axis. And so let's just pick, say, below median income parents. And since the graph is linear, we can just imagine taking the prediction from the 25th percentile of the parent income distribution. And so for Chicago, that's about just under 40. And so we can put that on a map and color code all of the different patterns. So for Chicago, we can see the red line, the red color there corresponding to about 40. So as you see on the axis here, it's about 40. But we can do this for all the other commuting zones in the United States. And this is generating this pattern of saying, if you're born to a below median income family, where on average does your child fall in the national income distribution when they grow up? And so what you see is that in the darker colors correspond to lower outcomes, the lighter colors correspond to higher outcomes. So there's broad swaths of the Midwest that tend to have pretty high outcomes, some parts of the Northeast that also have high outcomes. You see much lower outcomes along the Southeast, and also portions of the Rust Belt, so up in Ohio, in portions of Indiana. There's also a lot of kind of other patterns that you can see in the data. So for example, cities like Chicago, Milwaukee, Detroit tend to have lower outcomes. You can see that with St. Louis, Kansas City. These cities, these big cities, this will be a pattern, tend to have lower rates of upward mobility than kind of less dense, less urban areas. The second, oh yeah, go ahead.
So I was just curious because you mentioned that the children can be moving.
Yes,
right?
absolutely.
So I was just curious if you had looked at all of, this variation in the intergenerational mobility, how much it might differ by if the children are moving to different locations.
Absolutely, yeah. So one of the things you can do, and this is also related to the local ranks, is restrict to children who stay in the local area. Now, one of the things that turns out, so a lot of the kids, say in rural Iowa, the example I was giving before, a lot of the kids who reach the kind of upper regions of the income distribution, you'd find them as adults in big cities. And this kind of relates back to, when we say that outcomes are low in big cities, that's not saying that big cities are, playing no role in providing upward mobility for all of these places. What it's saying is, if you grew up poor in the big cities, then on average your outcomes are going to be lower than if you grew up poor in a rural area. Now, the interesting thing is if you do restrict to people who don't leave, you actually do get a similar pattern. So a lot of this is, another way of saying is, even within the people who stay in rural Iowa, you see that kids from low-income backgrounds tend to have higher outcomes. Relatedly, if you redefine all of the ranks to be local within these commuting zones as opposed to national, you get a similar pattern again. Now there you don't want to focus on just the outcome at the 25th percentile, that's sort of mechanical, but we want to look at the rank slope, so look at the slope of that line. And what turns out is that the places on this map that have very low rates of upward mobility also have greater intergenerational persistence. They have a steeper slope of that line. And so what that means is that even when you redefine things locally, you get a pretty similar pattern in terms of intergenerational mobility. Places where kids that don't rise up out of the bottom of the income distribution are also places where there's a greater gap in outcomes between the rich and the poor in the local area. All right. So this is the commuting zone level. We can replicate all of the analysis that I just walked through up to this point at the county level and put that on a map. And so this gets kind of fun. So now you can start to see some interesting patterns. So here we are in Chicago, inside of Cook County there. But you can see, before we had Cook County as this, Chicago as this big CZ here. When you open it up, you see that there's a lot of variation inside of Cook County. So here's us. That light-colored spot to the west is DuPage County, Illinois. It's where Naperville is. It's a place that has much higher rates of upward mobility for low-income kids than for people in Cook County as well. Some other patterns on the map that I haven't yet called attention to. So you might notice these kind of red patterns up in these areas here. So this is actually the Pine Ridge Native American Reservation. That's not an outlier. That's kind of a well-known, very high concentrated poverty area of the U.S. What else do we have here? other patterns. So you also can see that inside of Milwaukee. So this is one of another kind of example where going to the county level, you really start to see these big differences. You know, low-income kids in Milwaukee do worse than most other places, but you can see that's really concentrated in the downtown Milwaukee area, which is also, Milwaukee is one of the highest, has some of the most economic and racial segregation of all the cities in the U.S., and that's a general pattern that we'll talk about a little bit. A couple more patterns. So New York is another fun one. So you can see that the downtown areas of New York tend to be worse than, say, Long Island. So when you open up into the county, it can start to be illustrative. Okay, so enough of exploring the map. This is just showing observational differences of how low-income kids kind of fare in terms of earnings in adulthood. The question we want to get after now is, okay, so there's this variation in mobility across places, so what? Is this just reflecting the difference in kind of different types of people living in different places? Or is this reflecting the causal effect of place? If you took the same kid and imagine that instead of growing up in the Southeast, they grew up in the Midwest, would they have a higher outcome? That's the kind of causal question that we want to try to get some progress on to understand what is driving this variation in mobility. And so we're going to break that question into two parts. The first part is going to use this map as kind of a roadmap and ask if a child moves to a lighter shade county on this map, so it goes from kind of dark to light or from light to dark, does that change their outcomes in adulthood? And so that's sort of using these permanent resident outcomes on this map as a guide for trying to understand, is that kind of a proxy for how good a place is to grow up in terms of its causal effect on kids. The second question we're going to go after is to throw away this map that was made from kids who were permanent residents in a given place, and instead redraw that map, not with the observed outcomes of people that grow up in those places, but with the causal effect that each of these counties has on kids' outcomes in adulthood. And then we'll compare and use that comparison to try to understand a decomposition of the observed outcomes into a component that is driven by the causal effect that these places are having on kids, and a component that is driven by just the perhaps different people in different places. Yeah?
Okay, so before we move on, I have this question. This is the very first slide.
Yeah.
Are you focusing on two mechanisms, sorting versus causal, right?
Mm-hmm.
I'm not sure to what extent there is a dichotomy between them. Can it be just, I mean, I know it's a cliche,
Yeah.
but can they both? Like, they're not.
Absolutely.
So that they're incompatible with there's one mechanism and there's another one.
Yeah.
I think they're both play a role in segregation. So I just have trouble.
Sorry, if I implied that, yeah, so we're definitely not going to just say it's got to be A or B. What we're going to do is we're going to decompose this and say, to what extent is this, we're going to redraw this with the causal effect of the place. And then once we have that component, we can then interpret the remaining component as something that is not causal. And so then we have to interpret that, and just the term we're going to give to that kind of residual is going to be a sorting component. It's observed outcomes that are not reflected in the causal effect. So at the end of the day, we're going to come down and say, some of this is a kind of sorting component, some of it is a causal component, and we're going to try to understand how much each of these stories is playing a role, and then what are the characteristics in terms of types of places that have high causal effects versus have greater sorting components and things like that.
I believe it's in your MTO paper when you sort the differences between children who are less than 13 and teenagers.
Yes.
Are you going to sort of talk about children at different ages?
Yeah, that's going to be exactly the empirical strategy we're going to use to answer these questions. Yes.
I'm wondering, so people in the lower percentiles tend to be younger parents. So are you comparing your age 26, the age of the children, but the parents are all different ages?
Parents are all different ages, absolutely, for this map, right? So the way to think about that is, yes, you're more likely for P25, those parents are more likely to be young. That's absolutely the case. And so the way to think about that is, then there's sort of two different ways in which there might be geographic variation in these outcomes. Maybe there's different differences in the age distribution of parents across places that could be driving part of these differences. Or maybe it's just differences in different other sorting components that might be correlated with parental inputs. But the way to think about it is that absolutely, when we take a parent at a given parent income percentile, the low income parents are more likely to be younger. That's right.
Have you noticed any sort of correlation between a county or a commuting zone having a major college in it and the intergenerational mobility? I'm trying to figure out exactly
what's driving the pattern.
Where there might be, these colleges, but unfortunately I'm not great at geography. I don't know where the entire Big Ten is on the map. But
yeah, so we'll come back a little bit to the role of colleges and universities. So the basic answer is that this isn't going to be correlated much with the geographic allocation of colleges. We're going to find some other correlates that are going to be much more strongly correlated with this map. So measures of economic and racial segregation, measures of income inequality. The fraction of single parents in an area is actually going to be one of the strongest predictors of this pattern. So places where there's a higher fraction of single parents tend to have lower rates of upward mobility. We'll also see that this is correlated with measures of social capital. So even though it's not correlated with the number of colleges in each place or the kind of prestige of those local colleges, it is correlated with the number of bowling alleys in each of these CZs. Now, that's obviously not saying that if you build a bowling alley, you're going to increase upward mobility. Maybe we can have that debate. I don't think it's probably true. But it's suggestive that some of these patterns are reflecting some interesting things that we just don't fully understand. And at the end of the day, we're actually not going to reach the point where we're going to be able to say, here's the causal effect of a particular policy, like building a college or building a bowling alley or doing other things on mobility. What we are instead is going to go after a much kind of less aggressive question, but I think still difficult, which is to what extent is this actually reflecting the impact of those places? And then once you know that these places might be having an impact on kids, then we can start to uncover that black box of what inside the neighborhood is actually driving these differences in outcomes. And honestly, it's just we're not there in terms of being able to fully understand what is driving the differences. Other questions before we dive into the empirical strategy? Okay, so as suggested, so we're going to look at how are we going to get at this kind of decomposition and understanding to what extent, if you move to a place that has a lighter color on that map, to what extent would your outcomes be better? Well, we're going to focus on childhood exposure effects. So we're going to define the exposure effect at age M as the impact of spending that year M of childhood in an area where the permanent resident outcomes are 1 percentile higher, where the color on that map is 1 unit lighter. All right? And then we want to ask, on average, what does that do to kids' outcomes in adulthood? Now, the abstract ideal, kind of econometrically ideal experiment would be to randomly assign kids to these new neighborhoods, say neighborhood D, starting at some age M for the rest of their childhood, and force them to live there. Right? So that would kind of be, from a statistical standpoint, what you would want to do. If you had that data, you could then regress their outcome in adulthood on the mean outcomes of the permanent residents in that place. So if Y bar is the color on that map, we just regress the kid's outcome on the color of on the index of the color of the map separately for the kids that moved at these different ages, and then you get these coefficients beta M. And so then we would define the exposure effect here as the effect of spending that year of your childhood in the place, which is suppose you moved there 1 year earlier versus 1 year later, how much different are your outcomes? That's just going to be beta M minus 1 minus beta M. Okay. All right, so what's the problem? We don't have this experiment. Thankfully, we are not forcing kids to grow up in different places in a random fashion. And so what are we going to have to do? We're going to have to use observable just moves that people have at different ages in their childhood. And so we're going to basically worry then that we have an endogeneity problem, right? So what are the kinds of endogeneity problems you might worry about? Well, maybe the parents who move to a good area might have some latent ability or wealth. Let's call that theta. That theta is going to produce the child's better outcomes. And it's not necessarily going to be the place, but it's going to be a correlation between what the parents are doing and the outcomes of the people in the place. Okay? And so if we took the observational data and we ran the regression, we would come up with a coefficient that is the sum of two pieces. We would find both the beta m, the causal effect of going there at age m, but we would also get a selection component. What's the selection component? It's the covariance of the other inputs that parents who move to that place are providing with the outcomes of the permanent residents in that place. If good parents go to good places, then you would find that that coefficient is high, not necessarily because of the causal effect of going to that place, but rather because the types of parents that are moving there are doing other things that even if they hadn't moved there, their outcomes would be high.
What happens if there's like kind of positive selection for long distance moves in general? So even if they might be moving to a worse county, they're moving to like a better neighborhood or school.
Within the community, so how do we think about sorting within the county or commuting zone? So that's a great question. So we're going to kind of punt on this a little bit for now. And what you would end up finding in the empirical work is that you would see pretty extreme attenuation if there's sort of this countervailing effect. You would find that if you move to a better place, that if you move to a worse place and then you counter it by moving to a good neighborhood within a worse place, you would then see that in the data you wouldn't find a causal effect of moving to a bad place on the kids' outcomes. And so what we're actually going to find is pretty good evidence that the parents that move to the bad places are going to have negative outcomes in proportion to exposure time, and they're also going to be symmetric, so that it's almost exactly the inverse sign of the impact of moving to a good neighborhood. And so that's going to make us feel a little bit better about not being able to account for where within the geography the parents are moving. But it's certainly a good, an interesting and important question to think about how the neighborhood dynamics are operating within these counties and how that affects the estimates I'm going to walk through. And honestly, in our ongoing work, we're trying to go down to the census tract level to deal with some of that. Other questions? All right. Okay, so if we just took this off the shelf, took people that move across places, we would end up with a bias coefficient because maybe good parents go to good places, right? Now, what's the nice thing about identifying an exposure effect, though, is that we don't really care if good parents go to good places. What are we worried about? We're worried about the timing of when they go. Because what we want to ask is, suppose you moved there 1 year earlier versus 1 year later. And so the assumption that we're going to make and try to defend, but that a priori should certainly feel potentially ridiculous, is that these selection effects are not going to vary with the age of the kid at the time of the move. So put differently, we're going to assume that this selection effect is constant for kids of all ages. Okay? Now this is certainly potentially violated, right? So how would this be violated? If good parents don't just go to good places, but if good parents go to good places disproportionately when their kids are young, that would violate this, right? That would absolutely violate this. Conversely, if good things happen to parents that go to good places, and it's those other kind of good things that are happening that are driving the outcomes, and it's just correlated with, it just so happens to be correlated with where you move, that would also drive a bias in these results. And so we're going to want to come back and try to defend and think about this assumption and whether or not it's reasonable. But before doing that, it's going to be a lot easier to kind of make this defense after showing you some of the baseline results. And so let me just walk you through what you actually see when you look at kids that move across areas during childhood. And so to begin, let's just take the subset of families who move with a child who is exactly 13 years old. We want to regress now the child's income rank in adulthood or in young adulthood at age, say, 26. We'll play around with this a little bit on the predicted outcome of permanent residence in that destination. Okay? And so how are we going to do this? Well, we're going to regress that child's outcomes on a fixed effect for their cohort, their parent income level, and where they started at before the parents move. And then we're going to regress it on the color of the map, right? And you're going to get that B sub m coefficient. And we're going to interpret that as that the sum of the true causal effect plus that fixed component. All right, so to show you what this actually looks like in the data, what I'm going to do is residualize the left-hand side of the regression and slurp out those fixed effects. So we're going to regress the kid's income rank on fixed effects for parents' income, the origin location, and the cohort. We'll do the same for the destination outcomes of permanent residence. And then I'm going to show you the relationship between those two residuals in a binned scatter plot. So I'm going to take the residuals of the outcomes of permanent residence and bin those into 20 equal sized bins along the horizontal axis, and then on the vertical axis plot the average kid rank conditional on where they came from, their parent income level, and their cohort. And what you can see here is you get this increasing pattern with a slope of about 0.6, 0.62 or so. Kids that move, whose parents move to a place that is 1 unit better on when their kids are 13, on average, those kids have income ranks that are about 0.6 units better. Okay, so that's how you can interpret the observational patterns that you see when you look at kids who move at exactly age 13 in the US. Now we can, a couple things to note. This is linear. So coming back to some of the stories that we see before, you get a slope of about 0.6 if you look up and say, imagine a family that moves to a better place. You also get a slope of about 0.6 if you imagine a family that moves to a worse place. Okay? And so on average, you see a fairly symmetric relationship between moving to a better versus moving to a worse place. Now we can also look not only at when kids move when they're, the kids who move when they're 13, but we can also look at how does this vary based on the age of the kid at the time of the move. And so I'm going to take this 0.6 and plot that for the 13-year-olds. And so that's up at the 13-year-olds up on that slide. And what you can see is that the later you measure, or the later the kid, the age of the kid at the time of the move, the less that their outcomes are correlated with the outcomes of the permanent residence and the destination. Yeah.
Can you look for younger kids because their development is more sensitive in younger ages? So, but do you have access to?
So why do we start at age 9? Yeah, so we can go back to age 9 because our data starts in 1996. And so we actually can't, for these types of outcomes, go back much younger. One of the things we can see from this graph, so let's just walk through what we've got here, is that it's, if you move at age 9, you get almost 80% of the difference in the outcomes of permanent residence. If you move at age 23, you get basically 20, it looks like your outcome is correlated with at about 0.2 with the outcomes of the people in the permanent, in the destination, and that levels off above age 23. And so just coming back to this kind of linear exposure pattern, what you can say is that if anything, it looks like for this particular outcome of the geographic variation in mobility, it's got to be driven primarily by exposure during kind of young adolescence and kind of ages between 9 and 23, mainly because you wouldn't expect as you go back in time that line to go above 1. It could, there's some stories you could tell, but if you extend that perfectly back, it'll basically hit 1. And so that would be consistent with kind of early years mattering just as much as later years. But if anything, this graph is suggestive that kind of midlife, kind of ages between 9 and 23 are kind of the ages that tend to matter most for explaining that variation in mobility. The logic that I have in my mind on this, and Raj and I have gone back and forth, we have debates about whether or not this is going to be linear in 8 years when we're actually able to measure it. The model I have in my mind is that this goes pretty flat and flattens off. We kind of go back and forth. So if you thought of a Heckman model where early childhood investment is everything that matters and that kind of drives feedback effects, then you would expect a curve that goes up. So we can reject the ability for that to go up because just it would be bounded by 1. And so it doesn't look like, that's not to say that early childhood investment doesn't matter, but what it says is that geographic variation in early childhood investment is not what's driving the geographic variation in intergenerational mobility, if that makes sense. Everybody with?
Can you say that?
Say it one more part. Okay, so it could very well be the case that the impact that, what your parents do when you are 1 year old, so like, Gerber formula versus something else, you take your pick, right? It could very well be that drives huge impacts on kids' earnings in adulthood. I don't have anything to say on that, right? And so it could be the case that then feeds into the ability for kids to kind of go through school and have, so that you have to have a really good, good kind of childhood, early young childhood environment. What we can say on this graph is that in terms of explaining the geographic variation in mobility, differences in the extent to which people are doing different things to kids that are 1 year old does not explain the geographic variation in the map. reason is if you thought that exposure to different places when you were kind of 1 year old was, say, 5 times as important as when you were 9 years old, then you would say, well, geez, then that coefficient is going to have to go above 1 at age 1. And so we can rule that out as we extend it back. Does that make sense?
No,
Yeah.
yeah. But I don't know,
Yeah.
because like, I don't know if it would mean that it would pass one, because, I mean, the kids are not like, they have their parents that are educating them already, so,
Mhm.
I mean,
Yeah, that's exactly it, right? So what is this? So let me walk through the kind of what we think we're saying with it, or at least what we're arguing with this, and we'll come back to kind of what it means. So what are we saying here? So let's put assumption 1 on the graph. So what's the assumption? The assumption is that the sorting of different parents to different places does not vary with the age of the kid at the time of the move. So on the map, on the graph, that just means that there's a flat line going across here representing the sorting component. And we got pretty good evidence of sorting. So anybody see kind of clear evidence that basically not all of that slope is the causal effect of place? So we're measuring incomes at age 26. This is the coefficient when parents move at age 27, when their kids are 27. What does it tell you? Where parents move when your kids are 27 predicts their kids' income at 26. There's ways in which you can tell a story that that's causal, but it's tough, right? You know, it's more likely reflecting the fact that where parents move is not random. It's not orthogonal to kids' outcomes. And so at no point are we going to say where parents move is random. What we're going to argue, though, is that whether they move 1 year earlier versus 1 year later is going to be orthogonal to kids' potential outcomes. And I haven't established that yet, but that's going to be the end goal of what we're going to try to establish. And so what this shows is that every year a child spends in a better neighborhood, a place where the permanent residents are doing 1 percentile higher, increases the kids' incomes by 3.8 percentage points. Okay? And so this linearity means that basically every year of childhood exposure seems to be driving an impact. And so then coming back to the question of, is early childhood more important than later? Every year seems to matter throughout the sample range that we can see. We can't observe moves prior to age 9 in these cohorts, but if you extend the 3.8 going out and assume that it's still constant, then you would hit 1. If you thought that early years were more important, so that you picked up more of this kind of geographic variation, then you would expect this to curve up, and that's potentially implausible because it would be hard to imagine that if you move to a place where people who are permanent residents are doing 1 percentile better, that you pick up more than the difference. There's models where you can get that if there's some negative sorting patterns going on, so it's not statistically impossible, but it's arguably implausible. There's a question.
It can also be, at the same time, it could be better parents move earlier.
Exactly. Good. So that's what we were saying. So we're going to come back and defend. So this pattern, so what would violate this assumption, right? If good parents move to good places disproportionately when their kids are young, that could exactly generate this pattern. Now, it would also have to be the case that bad parents move to bad places disproportionately when their kids are young, because you see the same pattern when you look at moves that are to worse places. But it could very well be the case that you have this correlation with kind of when parents are moving. So how are we going to try to get at this? Well, we're going to try to do a range of things to try to convince you that that's not actually what's going on. And so I think this is a traditional approach to trying to deal with an exogeneity or an orthogonality condition would be to use an instrument or use kind of an instrumental variable strategy. And that's not exactly what we're going to do, because we don't think we actually have an instrument for getting people to move to every single place in the US. So we're going to do some different kind of more controlling based strategies that we're kind of excited about that hopefully will make some sense. So there's going to be 3 different strategies that I'll walk you through, but just to set these up, just to talk about the main concerns. So these concerns were largely raised, so people had looked at people that move across places in the past, not so much in administrative data like this, but there was a lot of work on place effects and thinking about potential biases in this wonderful Jensen-Meyer paper from 1990, where you just worry about the sorting of different families to different areas and also shocks driving movement to different areas. So good things happening to parents that go to good places. And so we're going to first try to tackle these things. And so the nice thing about these two concerns is that we can do a lot just with what we see in the data. So in particular, if you're worried that good families move to good, or good parents move to good places disproportionately when their kids are young, well then one way to think about that is to not identify that coefficient of that 0.038 coefficient from families kids who move when they're age 9 versus 10 versus 11, but look within a family. So imagine you have two families. One has a kind of 7th and an 8th grader, another has a 6th and a 9th grader. If you believe that place matters in proportion to exposure time, then you would expect to see an outcome, a difference in outcomes between those two siblings that are three times as large for the kids who move in 6th versus 9th grade versus 7th and 8th grade. Right? So put differently, we can introduce family fixed effects into that specification on the previous graph and identify only off of these age differences and differences in cohorts across the kids within the family. So slurp out that family component. And so when you do that, you end up with the following picture. And so what you can see is that the slope is largely unchanged. We're still at about 4% per year that you pick up. But the kind of level of the graph is shifted. It's kind of fallen down a little bit, consistent with the idea that you're soaking up some of that selection effect of parents moving to different places. Right? And so this deals with, I think pretty well, the sorting of different families to different places. If you thought that that pattern was driven by kind of good parents going to good places disproportionately when they were young, then you wouldn't have expected that the younger child would do better than the older child by 3.8 or by 4 percentage points per year of age gap in those siblings, right? But that's actually what you end up seeing in the data. Now, another concern though is that maybe the families aren't sorting on fixed characteristics, but rather maybe good things happen to families that move to good places. So somebody in your family gets a new job, you move to a good place, it's all bustling, and it's not that kind of outcome of going to the place that's doing it, it's just, you got the promotion and the income change is what's gonna drive that impact on the kids, and the people who get the income increase when the kids are younger, those kids are gonna do better than when their parents get the income increase when they're older. So that would be one potential concern that could be driving this variation. So fortunately, income is something you see quite well in the tax data, so we can control for changes in parental income around the time of the move, or just yearly parental income for each year in the sample, interacted with the age of the kid at the time of the move. And so if you squint, you'll be able to see what just happened to the coefficients. This is not what's driving the pattern. Now, those coefficients, the difference when you put in those coefficients on the change in the parent income in these regressions, the t-stat is over 100, right? So it's not that parental income and different parental incomes don't matter for predicting kids' outcomes in adulthood. It's just that those changes in parent income are not correlated with the interaction of whether you move to a good versus bad place when your kid is young versus old. It's that interaction where it's not seeming to confound that interaction. Right? So it doesn't seem to be the case that good things happen to parents that go to good places disproportionately when their kids are young. All right. So that rules out a couple of the kind of, at least for us, the kind of things we're most worried about kind of coming into this and trying to think about what could be the potential sources of bias in this exposure type of design. But this still does leave some things on the table for potential concerns, right? So what's another concern? Well, maybe there's some time-varying unobservables that we just didn't observe, right? Maybe when parents move to one of the best places on that map is Salt Lake City. Maybe when you move to Salt Lake City, it's because you just got some wonderful wealth shock or some other kind of parental capital shock, and you're like, I'm going to Utah and we're going to hang out. And it's not that Utah is doing this positive thing to kids, but rather it's just that shock that did it. And even if you hadn't moved, it would be that shock that would affect the kids in proportion to exposure time. And so these kinds of shocks are really tough, right? Because you don't know necessarily what they are, but you just kind of worry that this kind of stuff might be floating around. And so what we're going to do is develop a strategy to try to rule out the plausibility of those kinds of shocks. And so let me just walk you through kind of how this is going to work. We're going to use what we call placebo or over-identification tests that exploit the multidimensional aspects of outcomes across areas. So what do I mean by that? And let me just walk you through an example. So we started with that increasing linear slope for kids born in 1985 in Chicago. Now, we could have drawn that for kids born in 1984 or 1986 or 1983. We've got all those different predictions that we're forming for kids in these different cohorts. Right? Now you could also imagine a family moving into Chicago, and suppose they have a kid born in 1985. Now, maybe they do know that what the outcomes would be for the kids at their parental income level for that 1985 cohort. Remember, we're measuring that 20 years later when the kids are 26. But maybe they don't. Maybe they do, maybe they don't. What are we worried about? We're worried about the correlation with that particular outcome. So when the parent is moving, you could have imagined predicting the kid's outcome with the 1985 cohort, or the 1986 cohort prediction, or the 1984 cohort prediction. These neighboring cohorts could also be ways in which we could predict the kids' outcomes. If you think that what matters is the child's own cohort, it's sort of the model that we have in mind, is that what matters is kind of what the place is for your particular cohort, then you would expect that kind of the best predictor should be your child's own cohort. Moreover, once you condition on the child's own cohort, the other predictions of neighboring cohorts tell you something about whether or not there's potential selection concerns. Because in some sense, the story I have is what matters is the 1985 cohort prediction for Chicago. If I show you, if I tell you that, oh, well, then conditional on that, the 1984 prediction is predictive as well, that suggests, well, maybe I'm sorting to this place just because parents are deciding to move to that place based on some aggregate characteristic of the place. And so let me show you what the pattern is actually in the data. So if you take these different cohorts and you you construct predictions based on all these different cohorts, and you imagine predicting the kids' outcomes using the child's own cohort and the neighboring cohorts, you find that if you just replace the coefficients, you get very similar patterns. Outcomes across cohorts within places are correlated at about 0.9. When you put them all in at once, and you say, which cohort prediction in Chicago matters more? The 85 prediction for the 85 kids versus the 84 or 86 cohort predictions. What you see is the 85 cohort prediction is what matters. Conditional on the 85 cohort prediction, there's no predictive content from the other cohorts. And so what does this mean? If the patterns we see are driven by a selection pattern, it has to somehow be that parents are able to forecast the particular outcomes of that cohort, orthogonal to the neighboring cohorts. Conversely, if your model that generates bias was one in which I have a noisy signal of neighborhood quality, then you would expect my noisy signal to be correlated with all of those cohorts, right? So you'd expect more of a flat line with when you put all those coefficients in. But that's not what we're seeing. We're seeing a very sharp prediction, which is consistent with parents not actually sorting based on any kind of knowledge about these different cohorts. And it also suggests that there's a very strong cohort-specific component to these effects at the local level. Yeah?
I'm just curious about the implications of these conclusions. So 98 cohort, so that year is important, right?
No, this is pooling, sorry if I confuse it. This is pooling across all of the cohorts in the data, and what we're going to do is we're going to take that, draw that kind of hockey stick figure, and we're going to report the we're going to basically change the variables, that y bar variable that we're using to generate that hockey stick, and instead of using the child's own cohort, we're going to use neighboring cohort predictions. That's the red line. And then the blue line is putting them all in at once and saying which cohort, your cohort or the neighboring cohorts. This is the cohort 1 year younger, 2 years younger, 1 year older, 2 years older. Which of those is generating that pattern? And what you're seeing is that it's mainly the child's own cohort conditional on the other cohorts that's driving that pattern.
So I was thinking because I continue on the year 1995, and there's so many interesting economic reforms that have passed at the time that kind of began to dismantle the welfare state and what that served as a prediction. So those, I think those reforms also contribute to these staggering inequalities and lack of mobility.
Yeah, so I mean, we'll come back. I mean, so it's not clear yet. So TRA 86, it's not clear that that would affect a particular cohort differently. But one of the cool things that we're excited to see kind of going forward is to what extent do these kind of local, these different policies that have happened in the past affect these different cohorts differently, and try to use that to understand what might be driving the differences in in outcomes across place. But for this, yeah, I don't think the reforms in the are driving driving the patterns. Other questions? All right. So that's one of these tests. So we can do another different test. So this one might be maybe a little bit more intuitive. So one of the cool things that you see in the data, if you look so all the stuff we've been doing so far is looking at mean outcomes in the data, but you can also look at variances. So turns out that Boston and San Francisco have similar mean outcomes of permanent residents, but they differ in their variance. So more kids in San Francisco reach the tails. So there's kind of more people at the bottom, and there's more people at the top. What we can show now is, or what we can ask is, suppose you move to either kind of Boston or San Francisco, is the exposure that you get to San Francisco, does that cause you to be more likely to be in the tails of the income distribution? And so the answer is yes, in proportion to exposure time. So what this is doing is saying to what extent are you likely to be at the top 10% of the income distribution, or to what extent are you likely to be employed? For this sample, 10% of people are not employed, which makes you at the bottom of the income distribution. And what you can see is every year of exposure to a place where kids are more likely to be in the top 10% makes you 4 percentage points more likely to be in the top 10% of the income distribution. Conversely, at the bottom of the income distribution. And so you basically see that same exposure slope when the outcome is not the mean outcomes of these kid ranks, but rather tail outcomes as well. So put differently, outcomes of outcomes of people that move, kids who move across places, are converging in proportion to exposure time to the entire distribution of the income distribution of permanent resident kids in those different areas. Right? So if you move to a place where there's a wider distribution of of outcomes in that area, your kid will have an outcome that has higher variance, so it'll either be high or low, and with greater probability in proportion to the amount of time they spend growing up there. Right? And so you see convergence not only in mean, but also in variance and in these tails. Lastly, yeah?
And I was wondering, for a place like San Francisco versus Boston, do you or Raj have a story yet of what causes that wider variation in the first place? What accounts for that? So one thing that naively occurs to me is just the kind of gentrification that might be going on might very quickly, if you're moving to somewhere like San Francisco as a poor person,
Yeah.
things erode around you. It gets harder and harder to afford continuing to live where you do.
Yeah.
And you're looking at people who only move once. That's I think, right?
Pretty, yeah.
That's an important distinction we haven't really talked a lot about in
Right.
questions. So you're not going to see someone who moves to a certain I forget how it's restricted by county or CZ they move once.
So, so the short answer on the one move. So this is, as Trevor mentions, this is all people who just move once. So that makes kind of the analysis sort of simple. You can also generalize the patterns to be to have multiple movers that move multiple times. And what you see is that. So what's nice about having multiple movers is you can, let me do the multiple movers thing and I'll come back to the San Francisco thing. So one thing that we haven't talked about in terms of single movers is I'm calling this an exposure effect. But you could imagine that hockey stick thing is not an exposure effect, but it's a critical age effect. So maybe when you move at age 10 to a good place, it's not that you got 13 more years of exposure, of childhood exposure to that place, but rather it's that you moved at age 9, and that year of exposure between 9 and 10 is more important than anything that ever happened afterwards. All right? So how do you separate the idea that there's a critical age effect of, wow, I just have to move there at age 9, versus an exposure effect that the earlier I move, every year seems to matter in proportion to the amount of time, regardless of when I move there. So intuitively, what you need are two people that have kind of differences in the age in which they spend a year in a place, but both spend that particular, so they have the same exposure to the place, but differences in the age in which they go there. That would generate the identification for the critical age effect. With multiple movers, you get that. And so what you can see with multiple movers is that if you take somebody who moves to, the conceptual experiment you want to have in your mind is, you move to a place for 1 year and then you move back. And imagine you do that at different ages of your childhood. What you see is that the extent to which your outcomes change are the same regardless of the age in which you make that kind of yearly little loop through the place. And there doesn't appear to be in this data any significant critical age effects. The majority of this seems to be linear exposure effects. Now, what that means is just every age seems to matter the same. Like you can at some level you just say there's not a critical age effect, there's an age effect. Every year of being there at different ages in childhood seems to matter equally, but it doesn't look like any particular age matters more than others. Makes sense?
Well, at some level too, the moving for a year and going back might be picking up what it means to move as an event rather than
Yeah, so let me generalize it. So it's not just moving and back, but moving to a good place and back and versus moving to a bad place and back. So you want to difference out any kind of disruption effect of moving, which because we're looking at the interaction with Y bar, we're looking within the set of movers, right? So in some sense it might, so we're going to document the causal effect of places. Now, that doesn't necessarily mean you want to move people to good places, right? It might suck to move. And we're looking within the set of movers, right? So all we're asking is if you move to a good place versus a bad place. A distinction is, well, geez, if you want to think about policy, and we'll come to this with MTO, if you want to think about policy and you want to think of moving people, you better be comfortable that the act of moving, even though if you might get them to a better neighborhood, doesn't overwhelm any kind of positive effects of, or that the impact of the neighborhoods is kind of at least counterbalancing any kind of disruption effect of the move. But all this is kind of netting that out because we're looking within the set of movers. So coming back to the segregation thing within, I mean, I would think of that as just one potential reason that there is a difference in outcomes in a place is because of the geographic allocation of people to the place. And so that's a story of whether or not segregation has a causal effect on mobility. Don't know. We need exogenous variation in kind of rental policies or segregation policies, and we don't have it yet. Well, not that we don't have exogenous variation in segregation. I mean, somebody wants to code up the redlining maps from HUD back in the day. I'm sure we could find ways to do it, but we're not at the point in which people have done it. All right. Other questions? Okay. So the last sort of placebo or over-identification test that I want to walk through is to use gender. So outcomes across places are pretty highly correlated across genders. So correlation is about 0.9 when you're looking at family income outcomes. But we do see that low-income boys tend to do worse than girls in areas that have more segregation, in areas that have higher rates of crime, or areas that have lower marriage rates. Just tends to be an observational pattern. And so what you might now ask is, suppose you have kind of two kids that are of opposite genders. If you move to a place that is particularly good for boys, does the boy do better than the girl in proportion to exposure time? The answer is yes. What you see is, so this is doing, we can form predictions, basically redraw that map using gender-specific predictions. And so now each Y bar is a particular gender. And what you see is you replicate that pattern of a declining slope of about 3.8% per year when you use the own gender prediction. Now you can also kind of flip out the own gender prediction for the other gender prediction. So suppose you have a girl and you move to a place that is 1 unit better for boys. On average, that girl is going to do better because those are correlated to 0.9. When you put them both into the regression, though, it's primarily driven by the correlation with the own gender effect. So in other words, there's a convergence across places, both in terms of the variance, but also in a gender-specific way. So if you move to a place that is particularly good for boys, on average, your boys are going to do better than the girls in proportion to exposure time. Yeah. Where on average, boys' income rates are higher than 1 unit higher relative to girls. So we're just going to say on that map that we started with, let's just redraw the map for boys and redraw the map for girls. We're not going to say why it might be different, but we're just going to separately estimate the permanent resident outcomes for boys versus girls. And then we're going to say, suppose you have a boy and you move to a place that is 1 unit better for boys. Is that better for the boys? Is it better for the girls? And if you move to a place that is 1 unit better for the girls, is it better for the boys or better for the girls?
I don't know if it has to do with the place itself or with the gender. So maybe it's not that the place, if there's a place that is good for boys or girls, or it's just.
So what this is showing you is that if you go to a place where girls are doing 1 unit better than boys, holding fixed how well boys are doing, if you go to a place where girls are doing better, the girls will do better in proportion to exposure time, but the boys will not. And so that's ruling out a role of, I mean, that's not that they're ruling out a role of gender, but it's saying that there's a gender-specific way in which neighborhoods are affecting kids. If that makes sense. So what do we have? What are we left with? Yeah.
You said that
Go
was
for
for
it.
low income, as opposed for high income.
Oh, this is for, sorry, for these correlations. The pattern, this pattern is for everybody. Sorry, this pattern is for everybody. The places where you see greatest divergence between outcomes of boys and girls are in the lower regions of the income distribution, and they tend to be correlated with this, yeah. All right, so where does that leave us? So at the end of the day, any omitted, what have we shown? Any omitted variable theta that it's going to generate bias in the exposure effect estimates has to operate within the family in proportion to exposure time. So it has to drive those differences in outcomes across siblings in proportion to the age gap. It also has to be fully orthogonal to changes in parent income or marital status over those 17 years that we see in the data. It also, that theta has to replicate the permanent resident outcomes by birth cohort, quantile, and gender in proportion to exposure time and conditional on other moments of the distribution, right? And then also, I didn't show you this, but you also can replicate those same patterns across outcomes using income at different ages, college attendance, teen labor at younger ages, and also marriage. So the earlier you move to a place where more kids get married by, say, age 26 or by age 30, the more likely you are to get married in proportion to exposure time. And so we think this is pretty unlikely. You know, it's sort of like this data has to have exactly the number of dimensions equal to the number of places times the number of outcomes we happen to look at, which is, you know, a very implausible story. We think the more likely story here is that places are having effects on kids in proportion to exposure time. Put differently, we think it just matters where you grow up, and that loosely, we all look like a weighted average, on average, of where we grew up, where the weights are kind of proportional to the time we spent in each place, and the things we're multiplying by are the outcomes of permanent residence in those places. So that's loosely the kind of model that we think kind of fits this data in terms of trying to describe patterns that we see for kids that grow up in different places in childhood. Okay, so that's the first part of kind of where I wanted to kind of get to. And that sort of documents that on that map, when you move to a better place as defined by the color of that map, on average, if you go to a lighter colored place, your child's incomes will do better in proportion to the amount of exposure time they have in that place. What we haven't done is try to redraw that map and throw away the permanent residence and say, what is the kind of causal effect of moving to Tennessee, rural Tennessee or Chicago or another neighborhood? And so intuitively, what we want to do is kind of re-estimate 3,000 fixed effects for each place of what the causal effect is of growing up in each of these places. Instead of just that one exposure effect estimate that on average when you move to a place that is 1 unit better, you pick up 3.8 percentage points of the difference. All right? And so I'll walk through kind of how we're going to try to do this. So we'll at some point want to take a break. How are people doing? So to walk you through kind of the logic here, we probably want at least another 20 minutes, half hour, so we'll go a little bit past the 10:30, or we could take a break now and go for a little bit more of a marathon when we come back. What do you guys feel like? First mover advantage on this one if you've got a preference. What's that? Keep going. Done. All right. If anybody needs to get up and walk around, I won't be offended. And even if I was, you should just go. Okay. So what do we want to do? We want to estimate a fixed effects model that basically throws away the outcomes of permanent residence. Right? And so how are we going to get identification in this model? Well, imagine you've got kids who, just take the set of people who move between Manhattan and Queens. All right? Now, suppose you see that the kids who move from Manhattan to Queens at younger ages do better. Then you would infer that Queens has a positive exposure effect relative to Manhattan. Didn't need any outcomes of permanent residence to make that kind of a statement. That's just the logic that we're trying to apply of this exposure time logic to the model. Okay? And so mathematically, how can we state this? Well, we can imagine that each place has a fixed effect where every year you spend in that place, on average, would increase your child's income by an amount governed by that fixed effect. Right? And so how are we going to write this out? Well, we can imagine estimating a vector of exposure effects, one for each place in the US, where we write the outcome of a kid, yi, as, for looking at kids who move at age m, and have a total exposure, which is going to be that 23 years that we showed you in that graph. So if you move at age m, t minus m is the total amount of time you spend in that destination. And if you move at age m, you're going to pick up, for those number of years that you, after which you move, you're going to pick up a destination fixed effect, but you're going to lose the origin fixed effect, right? And then we're going to soak into some other fixed effects, the origin by destination. So we're not going to identify off of people who move, we're going to worry that the set of people who move between Manhattan and Queens might be a different set of people than the set of people who move between, the Bronx and Queens. And so we're going to include an origin by destination fixed effect so that we're identifying off of that experiment on the previous slide. If you see people moving from Queens to Manhattan that are doing, or from Manhattan to Queens that do better, we're going to use that to get identification on each of these fixed effects, right? And so this is just a fairly large number of fixed effects in a model. We're then going to allow them, remember we started with that graph in Chicago where you have that linearly increasing pattern of incomes as a function of parent income ranks. We're going to allow these fixed effects to vary with parental income in a linear way to be able to fit that pattern that we know is existing there in the data as well. Okay, so we actually now have, so there's 3,000 counties, so we actually have 6,000 parameters here. Each place has an intercept and a slope, right? And so we're going to identify this model. Just we're going to run a regression. So we have to do a two-step procedure that I'm going to. So just running the 6,000 fixed effects in Stata is not fun. So there's a two-step procedure described in the paper where we walk through kind of how you can actually estimate this in the data. I'm not going to kind of walk you through all the details of this, but actually if you're interested in this kind of computational stuff and you enjoy kind of the computational side, this is an active area of research both in kind of in public and in labor especially, these so-called AKM models of firm fixed effects and things like that you might hear people trying to decompose wage variation into kind of firm effects versus worker effects. This is very related to that line of work and trying to understand the role of firms and inequality and all that. Doing that requires estimating a large number of fixed effects. Here, we're estimating a large number of fixed effects. I think methodologically, we're making a lot of advances on those fronts today. So if you're interested in those areas, I'd be happy to talk more, but a lot of the references are in the paper as well. Okay, so you get these fixed effect estimates. So imagine we've magically estimated the model. You've got these fixed effect estimates, and what do you end up with? So to show you what these look like, I'm going to put each of these fixed effects in a blue dot on this graph. And the level of the fixed effect is going to be the vertical axis here. Okay? Now, for comparison, I'm going to bring back in the data we had in the first part of the talk here, where we've got outcomes of permanent residence for each of these different places. And I'm going to put that along the horizontal axis. Right? And if I draw a line there, the slope of that line is going to be that 0.038 exposure slope that we saw before. On average, if you move to a place where people are doing 1 unit better, the causal effect of that place is 3.8%. Right? That was what we established in the first part of the paper. But what are we seeing here with these different dots? You're seeing that there's deviations around that average. So in particular, Cleveland has a fixed effect that is above what you would have expected based on the outcomes of the permanent residents in that place. Right? So we can think of the outcomes of permanent residence as gamma is that 0.038 coefficient times the outcome of the permanent resident. And so there's now kind of two stories for what could be going on. So what's the fact? The fact is that movers in Cleveland do better than you would have predicted based on the permanent resident outcomes. So this is sort of where, yeah, go ahead.
These are movers to Cleveland?
Both. So the fixed effect, good question. So in order to get power, we're pooling people that move, we're doing a couple of different things. So we're pooling people that move, say, into, let's take the Bronx, Manhattan and Queens example. So we're imposing a symmetry that we're going to look at the people moving between Manhattan and Queens, but we're also going to look at people moving Queens to Manhattan. And then we're going to impose that basically each place has a fixed effect regardless of where you came from. Now, that could certainly be violated, and actually I think we have some statistical evidence to suggest that there are kind of pairwise specific potential causal effects. We don't have so for reasons that will hopefully become apparent pretty quickly, we're struggling for power in the sense of trying to estimate all of these fixed effects. So we're going to impose the fixed effect and kind of aim for getting that kind of mean effect of each place. And then future work go after the variance around it. Yeah?
I guess in my head I thought that that's what this origin by destination fixed effect was meant to capture somewhat, but you're saying there's a difference between the directionality?
Right, so the origin by destination fixed effect is going to capture the level effect. But if you think that there's a different exposure effect of Manhattan versus Queens on people that move in from Manhattan, if you think there's a different exposure effect that Manhattan has on people if they come from the South versus from the Midwest, maybe an easier way to think about it, like some people assimilate, some people don't kind of a thing, then you would imagine that would be a source of heterogeneity where, sure, it would be captured in the, some of it would be captured in the fixed effect. Where would it be violated here? Where would it not be captured is that you might think that the exposure effect is different for people that come in different places. What we've imposed in this specification is an additive fixed effect model that would basically assume that it's constant. And so if moves are relatively balanced so that you don't have these kind of systematic differences sorting on causal effects, then you would actually just recover the average causal effect of each place. To the extent to which there's not balanced moves, and this is related again back to the fixed effects literature on firm worker fixed effects and all the problems that you can run into, it's not exactly clear what you're estimating with the fixed effect model. And I think there's a lot of really interesting future work to do to figure that out. Yeah.
So if power weren't a concern, what would be the alternative?
If what, sorry?
If power were not a concern.
What would be the alternative model?
Yeah, what would ideally,
how
would you write this?
Yeah, right. So you would have a mu sub OD, right, where it would be the exposure effect of D versus O. And then you would have a vector of OD specific causal effects. You would ask the question whether or not beta OD or mu OD equals minus mu DO. That would be the assumption we're imposing with this linearity. And then you can also do so some things we've actually tried to do is a little bit of variance decomposition. So we actually think there is a specific origin destination effect that is operating there because you can do some variance decompositions to try to get at it. But we don't think we actually have any kind of precision to actually estimate any places, particular origin destination effect. Kind of the classic thing, if you're going after a variance or a distribution, you've got a little bit more ability to get at it as opposed to a particular estimate. Yeah, question? You're good, all right. Others? All right, cool. Okay, so back to the estimates. So we've got Cleveland that, oh boy, hit the wrong button, don't worry. So we got Cleveland that's doing better than the outcome, than what you would have expected based on the permanent resident outcomes. And so the question is why? Two potential explanations. On the one hand, it could very well be the case that we've just got a noisy causal effect. We tried to estimate 6,000 of these things. Maybe it's just noise. Sorry. On the other hand, it could actually be that Cleveland is better than you would have expected. And so we need to try to separate these things. What makes it difficult is what I didn't show you yet is standard errors. And so in all the previous stuff, all the standard errors were pretty tight. We didn't really need to worry about them. Because we were kind of going after one number. Now we're going after 6,000. We've managed to get back into the t-stat of 2 land. And so what you can see is it looks like, Cleveland has about a t-stat of 2.5 maybe on the difference between the outcome of that and the permanent resident outcome prediction. But there's a lot of noise in every one of these fixed effect estimates, right? And so this is problematic. One of the things you might have wanted to do is redraw that map with these fixed effect estimates and said, go to the good places. So what would be the problem if you took this data and just sorted it on the causal effect estimate? The stuff that would pop to the top would naturally be the ones that got the high draw on this from the sampling variation, right? And so you wouldn't get a forecast of a place's causal effect by sorting this data. You'd basically end up with the small places that had happened to randomly have a high causal effect estimate would pop up to the top. And so you don't want to actually use these fixed effects for kind of guiding where you'd want to grow up necessarily. It might have some information in it, but you have to be a little bit worried. Okay. So what are we faced with here? We sort of got a classic variance bias trade-off. On the one hand, these noisy causal effects provide some information because they're unbiased as a kind of measure of the outcomes of the causal effect of the place. But on the other hand, it's got variance because of the noise here. And so what we're going to do is use these things for three different purposes. We're going to use these to quantify the size of place effects. So just ask, how much do places matter? We're then going to use them to construct forecasts that you could imagine using to kind of guide families to quote unquote move to opportunity, so to speak. And then finally, we'll ask, what are the characteristics of good versus bad neighborhoods? All right, so where were we? We just estimated a whole bunch of really noisy fixed effects and don't know what to do with them. So let's figure out what to do with them. So we have a fixed effect for each place, and what are we going to do? We're going to try to first quantify the importance of place. So not look at any particular fixed effect, but basically ask, what's the variance of fixed effects? And so how are we going to do this? Well, can we just look first at the variance of our estimates? No, that would be pretty crazy, right? Because the variance of each one of our estimates is the sum of kind of two components. One is the true variance of the place effects, the underlying effects places have, but also a component that is driven by sampling variation. So you can imagine, anytime you have an estimate, a fixed effect estimate of kind of some true parameter you're interested in, you can write that as the sum of the truth plus the sampling error component, where if you've got an unbiased estimate, as we're arguing we've got, these unbiased fixed effect estimates, that epsilon is going to be orthogonal to the truth, right? That's basically the identification assumption, or what you get out of the identification assumption. So then if you take the variance of the total fixed effects, so if we went back and looked at this and said, what's the vertical variance in all these dots? So just take that variance. You'd get two components. You'd get the true variance, but you'd also get a component that is driven by the variance of the noise. So in other words, those bars are also partly driving variance in the estimates. And so we want to take out the component of the overall variance of those estimates that is driven by sampling variance in order to understand what is the variance of the true causal effect of places. How important are places? How much does it matter that you grow up in one place versus another? So in order to get at this, we can just think of taking the standard error. So how do we know how big the sampling area variation is? Well, the standard error gives us a measure of this, right? So we can think of constructing an estimate of the variance of the sampling component across all places as just the expectation, it's just replacing it with the standard error squared. So the expectation of epsilon squared is just this standard error squared. And so we can write the variance component that's driven by sampling variation as just the average standard error squared. So in practice, in order to understand the total variance of place effects, we can look at the total variance of our estimates, but then slurp out the component of that variance that is driven by sampling variation, which we can approximate with the average standard error squared. When you do that, you get the following numbers, which instead of just walking through a bunch of random decimals, I'll give it to you in kind of layman's terms. A 1 standard deviation better place corresponds to increasing earnings by about 0.18 percentiles, which put that into about 3% increase in earnings per percentile, means that a 1 standard deviation better county from birth corresponds to about a 10% earnings gain. So if you want to think of how important are places for driving kids' outcomes across places, a 1 standard deviation better county from birth corresponds to about, on average, a 10% increase in earnings. Okay? So that's sort of a quantification you can do with the fixed effects. The second thing we want to do with these fixed effects is to construct forecasts of good and bad places to grow up. And I don't mean to be too kind of normative in terms of good or bad, but places that are having high versus low causal effects on kids' earnings in adulthood. And so, what was the concern of just going to a place with a high estimate? Well, you might be worried that part of that is driven by sampling variation, and so you want to think about that when you make that decision. And so what can we do here? Well, in that graph where we plotted the fixed effects along that axis where we also had the permanent residence, you can see that there's really kind of two measures that we have for how good a place is. We have the mover sample, which gets us these unbiased but noisy causal effects. We also have the permanent residence that gives us there's a lot of permanent residence, and they give us very precise predictions for outcomes of permanent residence in a place. But they're biased. because you might be worried that the types of people that live in one place versus another are just different, right? And so what that suggests is that you kind of get information in both of these pieces of in both of these estimates. And so if you were going to imagine deciding where you might want to raise your kids, you might want to incorporate both of them. And you might want to do that in a way that kind of minimizes the mean squared error. You might want to construct a forecast that takes those two pieces of information and constructs a forecast so that if you move to a place that is forecasted to be 1 unit better, on average, you actually go to a place that is 1 unit better. That is the forecast we're going to now try to construct. And so how are we going to do this? So we're going to follow an approach that's pretty common in kind of the teacher value added literature, but is kind of growing in a lot of different settings. So let's just take a few examples here. So horizontal axis, again, is the outcomes of permanent residence. The line is the prediction you get from outcomes of permanent residence, taking that 0.038 and multiplying by the permanent resident outcomes. And then the dots are the fixed effect estimates with the standard errors. Okay. And so what are our two estimates? We've got the noisy causal effects. So Cleveland is the example we were running with before. And we've got the biased but precise permanent resident forecasts. Okay. And so what are we going to end up doing? Well, we're going to construct forecasts that are basically going to incorporate this piece of information and that piece of information and say how much weight should I put on this piece of information versus this one. And so it turns out the optimal weight that you're going to want to put on these different forecasts is going to be inversely proportional to the standard error of this. Why is that? Consider the following experiment. Imagine we had no standard error on Cleveland. You perfectly precisely estimated that causal effect. Well, then you would just be perfectly comfortable saying that, well, Cleveland's better than you would have thought. But if you have a really wide standard error, you're going to be a little bit more worried about that. And so from a mean square error perspective, you're not going to want to actually be too comfortable with that, with that kind of noisy estimate. Instead, you might want to kind of shrink back and accept a little bit of bias in order to reduce some of that noise. Okay? And so this is a slide that works through the optimal formula, which is basically driven by signal to noise ratios. And so this is just walking you through the math on that. And at the end of the day, you can kind of get a graphical representation of how these estimates actually work. So here's the optimal forecast for Cleveland in the red, right? It's a weighted average of these two with the weights inversely proportional to the standard error. In Chicago, you get a similar weighted average thing where here, in Chicago, you're going more towards the point estimate because you have a lower standard error. Similarly, in New York, you're going more towards the point estimate. But in Santa Barbara, you're less comfortable with going more towards the permanent resident estimate. So these red dots are kind of biased in a classical sense. They're not unbiased they're not unbiased point estimates of the causal effect. The expectation of the kind of estimate given the truth is not equal to the truth. But they're optimal in a Bayesian sense. The expectation of the truth given the point estimate of the forecast is equal to the forecast. So hopefully that tongue twister didn't confuse you too much, but the way to think about it is, if you look vertically at those red dots, if you go to a place where the red dot is 1 unit higher, on average, that causal effect will be 1 unit higher. You don't know exactly if that particular place is going to have a higher causal effect, but across the sample, when you look at a place that has a red dot that's 1 unit higher, on average, that's going to be correct and 1 unit higher. Right? And so that's basically what we're going to do. Yeah?
So of course, these are always going to be shrinking the effects closer to the line. And so I am a little familiar with the teacher value added literature. This is just like that Bayesian shrinking.
This is James Stein. Yeah. This is the fact that you get a weighted average of this is exactly James Stein, and this is the shrinkage to the mean. Absolutely. So there's this James Stein is this kind of classic result that if you just take point estimates and you want to actually do something with them in kind of a Bayesian sense, you want to make a decision based on them, you kind of want to reduce a little bit of the noise in them by just shrinking them to a mean. And so it's this similar result. This is also, you'll hear terms like ridge regression. This is also close to identical to ridge regression. So you're kind of minimizing mean square error. That corresponds to putting kind of weight on different variables, kind of inversely proportional to the standard errors. All right. Okay, so there's our formulas. So now what I want to do is just show you a whole bunch of these red dots on maps. So the forecasts for different places. So here's Chicago. So just zooming in, what you can see is kind of Cook County has kind of lower outcomes relative to DuPage County. So just put some numbers on this. We scale them into kind of percentage impacts on kids' earnings in adulthood. So every year of exposure to DuPage County increases a kid's earnings by about 0.75% relative to the national mean. Cook County decreases 0.67% per year. So if you kind of take a weighted average of this thing, if you take the difference and multiply by 20 years, say, of childhood exposure, the difference in a kid's outcomes of growing up in Cook County versus the western suburbs of Chicago is about a 30% increase in kids' earnings. So large differences even at small geographies in terms of the impacts that you expect to see on kids' outcomes in adulthood. There's also an interesting experiment that we probably won't have too much time to talk about called the Gautreaux housing experiment that happened back in the 60s that resettled as part of a lawsuit that resettled families from concentrated public housing in Cook County largely into DuPage County. And there was some observational work just kind of documenting the difference in outcomes for kids in those two sets of families, the ones who got the opportunities to move out of the housing projects versus those that didn't. And they found large increases in earnings. A concern in that was that there was endogenous selection into who decided to move, and so it's sort of been unresolved whether or not that experiment was, or that settlement led to actual increases in kids' outcomes. What we can say here is that you would actually expect to see a 30% increase in kids' earnings as a result of that experiment, is one way of thinking about it, and in practice that's not too far off from where people found it. They found like 30 percentage point increases in college attendance and things of that nature. All right. That's Chicago. Here's New York. New York's fun because counties correspond to boroughs, and so you can kind of put a little bit of kind of easier interpretation on things. One of the things I really like about the New York map is that you again see this kind of high variation even at small geographies. So you can call your attention to the difference between Bronx and Bergen County. So Bergen County is just right across the river. Even Hudson County, this is basically Hoboken, New Jersey versus kind of downtown Manhattan. So this Manhattan point you can kind of think of as kind of being the downtown area, and especially Harlem, and then the Bronx area to the north. Again, put these differences in percentage terms, multiply by 20 years. Multiply by 20 years, and you end up with increases in earnings of about 25% if you grow up in New Jersey as opposed to New York. And so that's sort of surprising that you see these kinds of impacts at very low distances. This is for high-income kids, so this was for low-income kids, this is for high-income kids, and you see broadly similar patterns. So the general pattern that you see across areas is that places that tend to promote high outcomes for low-income kids are also places that tend to promote high outcomes for high-income kids. There doesn't seem to be a huge trade-off, so you could have imagined, one of the common questions that kind of comes up with this stuff is like, is there kind of a trade-off between providing good outcomes for low-income kids versus good outcomes for high-income kids that you see? So, private schools and income segregation within a place can kind of potentially generate that, at least in kind of the cross-section of the data that we see. Places that tend to be promoting good outcomes for low-income kids are also places that tend to promote good outcomes for high-income kids. Doesn't rule out the idea that there's a trade-off going on, but that trade-off is certainly not what's driving any of the differences that you see across areas. Here's Boston. Again, just wide variation at local levels in terms of the causal effects that these places have. And just to kind of sort, so one of the nice things, once you have these forecasts, we can now sort them, right? We're not worried that what comes to the top is just driven necessarily by noise. We think that on average, the place that pops to the top, on average, it is actually going to have a causal effect that falls in that predicted forecast range. So the county with the highest causal effect in the U.S. Amongst large counties is DuPage County, Illinois, just the western suburbs of Chicago here. The worst is Mecklenburg, so that's Charlotte, and then Baltimore City, which is downtown Baltimore. So just to put, again, numbers on this, the 0.8 versus minus 0.7, for every year a child spends in DuPage County, Illinois, relative to Charlotte, their incomes are 1.5% higher. So 20 years of exposure is about a 30% increase in kids' earnings in adulthood. Yeah?
Could one explain, for instance, the effect of Cook in a particular region of the Cook County?
Yeah, very good. So, right, so what you want to have in mind is, and this is kind of implicit in the Manhattan thing as well. You know, who are the parents at the 25th, like where are the parents of the 25th percentile living within Cook County or living within Manhattan? And likely they're in Harlem, or likely they're in lower income areas in the neighborhoods. And I think the way we think about it is that there's kind of the parent income level is kind of identifying a surface within the a subset within the aggregated geography. And I think that's a lot of what the parent income level is doing to help us deal with kind of some of the sorting to different places within a geography. But certainly opening this up within geographies, that's what we're working on now, is going down to the census tract level and redrawing this map at the census tract level. And it's
the south side, I guess, of Cook County is the one that is driving this negative.
Yeah, so actually I can speak a little bit. South side of Cook County and the west side are the two places that are kind of, at least based on the all anecdotal evidence, would be the places that are driving a lot of these patterns. Yeah.
With this data, do you ever attempt to calculate the parent-child income elasticity? So a lot of times with the intergenerational literature, you see log parent income, log child income,
Yeah.
beta, there's the elasticity.
Absolutely.
Do you do anything like that with this, or do you mainly stick with the effect for the 25th percentile?
Yeah, exactly. So on the intergenerational elasticity is a measure of relative mobility. So it's asking if your parents have 1% higher income, how much income do your kids have on average? And so that is similar to the rank slope that we showed for Chicago at the start. And so we do show that one of the things we show is that if you compute that slope and you compare the slope in each place to the level of kids' incomes at the bottom, they're very highly correlated. And so what does that mean? It means most of the variation in the outcomes for low-income kids is driven by variation in relative mobility, whereas there's not as much variation in mobility up at the top. So in some sense, the geographic variation in relative mobility is very related to the geographic variation and kind of upward income mobility for low-income kids. And there just is less variation in mobility for rich kids, so to speak. Coming back to the log-log specification, so we talk about this a lot in the 2014 QJE paper. In the first section, we characterize the national income joint distribution of incomes of parents and kids and do the log-log specification. What happens when you take logs, and this is the kind of canonical way of doing the intergenerational income analysis, is that you end up having to deal with zeros of kids' incomes in kind of unsatisfactory ways. You drop them. And so, for kids who are 30 years old, 10% of them are not working. Some of them are kind of permanently out of the labor force. And so there's a question of what do you do? It turns out you can pretty much replicate any intergenerational elasticity you want by adding a number between 0 and 1, right? And you either drop them or you start adding epsilon. Now all of a sudden you're giving an insane amount of weight. So why is that? It's because kids who are not in the labor force are disproportionately from low-income families. And so you can accentuate the income gradient by as much as you want by giving that arbitrarily high weight. In contrast, if you do the rank transformation, you get stability that has been established now in a wide range of data sets that doesn't suffer this problem. And so you just assign kids that are out of the labor force the mean rank of kids that are out of the labor force. So for example, 10% of our kids are out of the labor force. They all get a mean rank of 5. And so that then generates that linear pattern, whereas with the log-log pattern, you don't get a linear pattern. Then even when you restrict to positive income in the log-log pattern, you get a curved pattern where the slope between the 10th and the 90th percentile is steeper than the slope up at the top. And so then differences in kind of parental income sampling can generate differences in elasticity. But in contrast, when you do the rank slope, it looks to be much more stable. And so we do a lot of this kind of distinction between relative and absolute mobility, but in our view, the focus on log-log is a poor way to characterize the joint distribution of parent and kid income.
It seems to have all these couples here that are really.
Sorry, what?
There are couples of counties that are on both sides of this table. So
Yeah.
Do you do some kind of measure of segregation based on these causal effects as well?
So we're going to correlate them with segregation in a second. Is that? Are you thinking of?
Segregation in income and there's segregation in mobility.
So are you thinking? They're going to be spatially autocorrelated. So if you're in a county, on average, the county next to you is going to have a high. If you're in a county with a higher causal effect, on average, you're in a county that your neighboring counties have high causal effects. But there are some examples like Bergen and the Bronx that have these kind of countervailing patterns. Yeah. Yeah. Okay. So here's the top 10, bottom 10 counties for low-income families. You can split this. You can do this for high-income families. So now Fairfax, Virginia, or Westchester, New York kind of rises to the top. Downtown Manhattan is not great. Los Angeles or some places in California tend to not be all that great. Palm Beach, Florida. We can also go back now to low-income families and split it out by gender. One of the things we see in the data is that there's particularly strong negative effects for boys in the worst places. So Baltimore there, you can see it jumped all the way down to minus 1.4 versus kind of Bucks County, Pennsylvania, or Bergen again, or above 0.8. So if you take that difference, you're above 2, so that's about a 40% increase in earnings for a low-income boy to get out of one of those bad neighborhoods when young. There's a way of interpreting it, and you don't see as big of effects. So now look at the 0.77 for girls versus, again, 0.8. So it's still a 30% increase in earnings, but it's 40% for the boys, 30% for the girls if you aggregate across 20 years of exposure. So put differently, it looks like kind of bad places tend to matter disproportionately more for low-income boys than low-income girls, which is consistent with some other work that kind of suggests that kind of boys are more susceptible to exposure to disadvantage during childhood. I don't want to say we have specific support for those theories, but there's some work out there that cited a little bit earlier that has explored those patterns. Yeah.
Do you know anything about kids from single parent households versus nuclear?
Yes. So that's actually one thing we see quite well. The estimates are very highly correlated if you break it out for single parent versus two parent households. Most of the, and related to your earlier question, most of the parents at the bottom of the income distribution are of the single parent, so I don't know if actually most, but they're disproportionately represented at the bottom. What I don't know is if we've done the tails, like this full ranking by two parent and single parent. We do, I believe, have all of the data in the online data tables that would allow one to replicate this actually by a single parent.
But when you're comparing the parental income you're comparing it to, that's just for one parent, or is that for?
It would be aggregating across the parents, yeah, exactly. So that's why most of the parents at the 25th percentile would be more likely to have just one earner. Yeah, but you can do, so we would hold the ranks fixed kind of across that definition, but when we go to the single parent samples or two parent samples, you can then re-estimate everything within the subsample of kind of single parent and two parent households, and you should be able to replicate all this. I don't believe we actually have the forecasts of this online, but we have the individual estimates split out for single and two parent households that would allow for a replication of this.
Do you look at changes, so divorce or death of a parent? Be able to see in the final
Yeah. So we look at divorce and changes in marital status as a control in some of the earlier work because we're worried that could be a shock that's has differential effects by the age of the kid at the time, and it also might be correlated with moving to a good versus bad place. We don't sort of we have so far primarily focused on just kind of a single measure of when when the child is first claimed in the data, are they claimed by a two-parent or single-parent household? And we follow those parents over time, but we haven't split the estimates separately by do your parents divorce versus not. Samples get a little small on that front, but it's probably something one could try to tease out. It's interesting. Yeah, others? Cool. All right. Okay, so that's sort of constructing these forecasts and thinking about kind of where are the good places and bad places to grow up. Now we can kind of ask questions that's a little bit different, which is what are the characteristics of good versus bad places? And this is motivated by the observation. If you look at that map that we were showing, there's strong correlations just in the outcomes of permanent residence across places with measures of income inequality, segregation, a fraction of two-parent households and things like that. And so it raises the question of whether or not those patterns are driven by a kind of correlation with the sorting component versus a causal effect. And so what we want to do is try to decompose that into kind of two different correlations. So a way to think about this is, we've estimated these causal effects which are the causal effect of 1 year of exposure to a place. Now, to a rough approximation, if you multiply by 15, 20 years of kind of childhood exposure, you get an approximation to what you might think kind of childhood exposure to a place does. And so let's call that kind of the causal kind of component of a place. Now, we also see outcomes of permanent residence at that same parental income level in that place. Let's call that YPC. If we subtract out the causal effect component of that, we're left with sort of everything that's left. Now, there's a lot of things that could be going into the everything that's left, but we're going to call it the sorting component. It's sort of the things that aren't explained by the causal effect of exposure. All right? And so we're going to now take these different components and regress them on stuff and try to understand what are the characteristics of places that have high causal effects or high sorting components and do a decomposition here. And so I'm going to show you a bunch of regressions on standardized covariates where we're going to standardize the covariate so you can think of a 1 standard deviation increase in the covariate. What's the correlation with the causal effect or the sorting component? And so we can do this decomposition graphically here. So one of the things that we've seen in just looking at the observed variation in mobility is there's a strong negative correlation with racial segregation. Places that are more racially segregated tend to have lower rates of upward mobility for permanent residents. That correlation is about minus 1.5. That regression coefficient gets you about 1.5 when you regress the Y outcome of permanent residence on the standardized covariate. We can also regress the causal component on that racial segregation measure, and you get another number, which turns out to be slightly smaller, but comprises the majority of this thing. Right? And so what does it say? It says most of the pattern, most of the correlation you see with racial segregation is actually a correlation with the causal effect of that place, as opposed to a correlation with the sorting component. Okay. And so there's still some correlation with the selection, but it's mostly the causal effect. Now, just to be clear, this does not say that changing racial segregation will cause a change in intergenerational mobility. Right? That may or may not be true. That's just not what this is saying. What this is saying is that places that tend to have high causal effects on kids tend to be places that have lower degrees of racial segregation. Okay. Now, it could be that they also have other things too that is actually what's driving the causal effect, but that's the correlation that we're seeing. Okay. And so how is that different from what you could say with just a correlation with the permanent residence? Well, before it could have been that there were just different types of people in places that are more racially segregated. That's what we're ruling out. Places that are more racially segregated, on average in the US, have negative causal effects on kids. If you grew up in a racially segregated place, on average, your outcomes would be worse. Now, we don't know if that's because of the racial segregation, but we know you would have outcomes that would be worse on average, right? So we can kind of move halfway down the line here. Okay, can also do other correlations. So Gini coefficient, so places with more income inequality, on average in the US, places that have more income inequality cause lower outcomes for low-income kids. Places that have more top income inequality also cause lower outcomes for low-income kids. Places that have higher rates of social capital, so this is an index that includes the bowling alleys, but actually is primarily driven by the fraction of people that return their census forms and the voter participation rates. It's an index constructed by Rupa Singha and Getz in a nice paper. Places with a lot of social capital tend to have high causal effects on kids. Places where there's higher dropout rates have negative causal effects on kids on average. Yeah?
So this is kind of related to a previous question, but so was like school district considered as one of the potential predictors for the causal effects? School district, or like whether that area has like a good school.
Yeah, so that's exactly, so it's kind of what we're getting at with the dropout rate. You can do test scores too, and you see a similar kind of pattern. Because we're looking at the county level, there's a lot of school districts within the most of these counties, and so one of the things we're very interested in, kind of going forward, is to kind of look for kind of school district boundary effects and see if does mobility vary on each side of the school district boundary, things like that. But that's not something that we've done, but could be something one could do to try to tease out causality. Yeah, Trevor.
I think it's reasonable to predict that different of these predictors might be at work in different geographies. Mm-hmm. And one first cut of that might be interesting would be either urban versus rural, or suburban? Because that's really implicit in what you show. Like when you show the maps, people tend to see a lot of the rural, just because geographically that's disproportionately big on a map. When you restrict to the top 100 out of the 3,100 or so counties, we see just the big ones. And I bet, civic participation might be different, just for one.
Yeah, absolutely. So, these are all weighted by population on these correlations. You see, so income inequality tends to explain more of the rural variation. Segregation tends to explain more of the urban variation. That's one of the patterns you do see when you do that kind of a cut. But I agree. I mean, that the kind of fundamental processes that are driving good and bad neighborhoods could differ dramatically in urban versus rural areas. Yeah.
I don't know if you have tried to explore also these correlations using some sort of amenities. I was surprised with the fact that New York was at the bottom for the frameworks again.
Yeah.
So I was trying to. I wouldn't have.
And males.
Males, yes.
Yeah. Manhattan. Yeah.
Yeah, I wouldn't have thought that living in New York was bad.
Right. So this is remember for the 1980 to like 86 birth cohort, and 80s and 90s in in Manhattan and is not exactly known as kind of the heyday in terms of crime rates. So crime rates have come down dramatically over time, especially in the cities. There's also some work that Pat Sharkey has done looking at this a little bit more, looking at the kind of crack epidemic and the response to the crack epidemic and some of the police force increases over the same time frame. It was largely kind of driven by some of the crime experience in New York and sees, so just brief aside, there was a 94 Clinton crime bill that increased the number of community policing officers in a range of different cities. And Pat Sharkey has a nice paper with some colleagues, some of whom have gone through this program actually, who look at a difference in difference estimate of the impact of that on intergenerational mobility using our estimates and the cohort level estimates that we have available for college attendance, and sees that community policing seems to have generated an increase in upward mobility through a reduction in crime. It's, there's things one can quibble about with the difference in identification assumptions, but it's pretty interesting, I think. But I think it's also kind of related to your question of kind of, what's going on in New York. I mean, these places are, don't want to say that no places are changing. There's certainly, I have some slides at the end here. We can talk about how things change over time, but there's certainly some kind of neighborhood changes over time, and New York is probably one that is getting better. Yeah.
I can see how housing costs could sort of be subsumed in maybe like one or two or three of these measures. Do you look at it explicitly?
Yeah, so it's negatively correlated with housing costs. So places that are cheaper actually have better outcomes. And that's largely urban versus rural. And that's a pattern you even see within commuting zones. Rural areas just seem to be better places to grow up in terms of having high causal effects on incomes, and they're inversely correlated with prices. In segregated neighborhoods, in the last section of the paper we talk about this a little bit, there seems to be an income gradient that pops up. If you look at large CZs and particular CZs that are segregated, then you see that it does look like it costs more to go to a better neighborhood.
And just one quick follow-up. I assume that the next graph is P75, or is that?
So this is P25. This is the 25th percentile. Do I have P75? I was going to unfold a couple more for you, but let's see what we got. Nope, I took it out. Don't care about the rich kids, I guess, today. No. I took it out for brevity. The correlations, I can give it to you. So these three are less important for the P75. The social capital is actually a really strong predictor. Actually, no, I shouldn't say that. Racial segregation is less correlated at P75, but inequality is correlated at P75, but not as much as P25. And so one of the cool corollaries of that is places with more inequality tend to cause greater intergenerational persistence in incomes. Right? Now, it's sort of It's not the most sort of salient thing because they're also bad for both rich and poor kids, but they do tend to, on average, look like they slightly increase in intergenerational persistence, which relates to this Great Gatsby curve literature. I don't know if anybody has followed some of this stuff, but there's a cross-sectional correlation across the world. When you look across countries, places that have greater inequality also tend to have greater intergenerational persistence. And so there's two natural stories for why that might be. One is that there's, in places with more inequality, you could think of kind of a core genetics model where there's just greater underlying heterogeneity that is both driving the cross-sectional variation, but also the persistence over time. So imagine just a simple model. Your income is equal to your parents because you have the same genes or whatever, and so your incomes are more persistent. If you're then in societies that have kind of greater heterogeneity, and then you would imagine both greater income inequality and greater persistence. So what we can see is you see a similar cross-sectional pattern in the US, that there's greater places, areas where there's more inequality have greater intergenerational persistence. But what we can do is we can rule out that theory, that genetic type theory. What we can see is that the exposure effects are actually driving persistence. So if you move to a place and you're a high income kid, or you take two kids, one's high income, one's low income, they move into a place that's is more unequal, there will be a greater difference in their outcomes on average in adulthood. And so in that sense, it looks like places are actually having causal roles in driving differences in income inequality across generations. All right. Okay, so that was the first kind of three kind of characteristics of places. Yeah. Sorry, I missed your question earlier. I should.
So I wonder if you looked at this for different races.
For
different races.
For different races, right. So yeah, so fortunately or unfortunately, people don't report race on their tax forms. So we don't see race in the data. It is something that we are certainly, you want to be able to try to estimate the causal effects of heterogeneously by race, right? So very salient is like Salt Lake City looks like a wonderful place. It's also not the most racially diverse place either. And so you might wonder is it the best place for everybody? Is it the best place for one particular race? We don't know the answer to that question at this point, but it's something that we're hoping to be able to do in the future, but it's definitely a limitation of the data right now. Yeah.
Yeah, one thing I keep thinking about is, especially if we have this focus on outcomes of children who are moving into these cities or these regions, there's also the impact of, or what's happening with people that are left behind, and if we would see some sort of effect based on like an outflux of the population from a particular area, particularly if those are the people who are wealthier or have higher ability in some way. And I mean, I think that's kind of associated with like Wilson's argument, which is like what is causing these religious effects is like the outflux of people from these areas. And I think
Absolutely,
that's salient with like the policy implications of this. If you're like encouraging people to move to like these high mobility places, and I think that's always a tension with like these sort of choice-based policies. So I was just wondering what you think about that.
I couldn't agree more. I think the question of to what extent is there, the question is what happens to the people left behind when somebody moves? That is, I think, there's two pieces that are, if you think about, so we'll get to a few slides that are going to show if you give kids vouchers to move to a better neighborhood, or if you take this evidence and look at people moving to better neighborhoods, it'll increase their outcomes in adulthood. Does that mean you should have a policy that helps families move to better neighborhoods? That is wholeheartedly not clear. It may very well be the case, but it may not be, right? You might be worried about the people left behind. You might also be worried about NIMBYism and what happens to the neighbors of the kids next door. I'll let you take your social welfare weights and put weights on all these different outcomes and figure it out for yourself. But the key input we don't have yet is those causal effects. It's really hard to estimate the impact on the neighbors, and it's hard because it's just such a diffuse effect, right? So if you think of the advantage we have with this design is that we've kind of got the kid moving. And so you can think of that kid as getting a large change in exposure. When that one kid moves into that neighborhood and goes in and there's several other thousands of kids in that county, it's hard to imagine teasing out the causal effect that kid has on all the other county residents, or conversely, what the kid does to the origin residents. And so from an empirical standpoint, it's a hard number to get. It's kind of, in my mind, kind of those two numbers, the impact on the kind of spillover effects on the destination and on the origin, they're kind of the holy grail in place effect estimates, because once you have those, you'll know exactly the answer to the kind of the question of how should you think about allocating. Well, you won't know the answer to how should you. You know the answer to what happens if to everybody if you imagine kids growing up in different places. So you can kind of do that conceptual experiment and then think about the trade-offs involved. And you're absolutely right that at present, we've got the impact on the kids, but we're sort of not talking about everybody else. And I think that's an important thing to keep in mind, especially that's going to come front and center when we talk about place versus choice-based policies. Yeah.
I was wondering about those who are on the other end of the income spectrum, those who are better off. So if you grew up in a racial segregated county, but your parents are
At the top of the income distribution? Yeah, so sorry, I was saying that earlier that the racial segregation is not correlated with the causal effects of parents at the top of the income distribution. Income inequality is negatively correlated, and that relates to the Gatsby discussion we were talking about. And social capital is positively correlated for kids at the top of the income distribution. So I'm going to throw a few more up here. So these are kind of measures of place characteristics. And then the last three I want to put up here are kind of measures. So in all these, the kind of causal components is kind of equal to or almost as large, or some cases larger, as the kind of correlation with just the total permanent residence. There wasn't much correlation with the sorting components. In contrast, for some of these estimates, the fraction of single parents in the area, you see a really strong correlation with the permanent resident outcomes, but it's cut in half when you look at the causal component. And so that's sort of intuitive that maybe in places where there's a higher fraction of single parents, maybe there's partially just an effect of growing up in a single parent family, but there's also an effect of growing up in a place where there are more single parents. And so this is showing you the causal effect of growing up in the place where there are more single parents, regardless if you are in a single parent or in a two-parent household. Similarly, with fraction foreign-born or fraction African-American, so we can't do the estimates separately by race, but we can ask what is the correlation of the average causal effect with racial shares at the area, and you can see that growing up in an area where there are a higher fraction of African Americans on average tends to cause people to have lower incomes. And so one thing you can do with this is you can say, suppose that the effects of places are constant across races. You can use it to do a decomposition of how much of the black-white earnings gap is driven by the differences in the counties in which low-income blacks versus whites grow up. And so you can show that this estimate at the bottom, that about 1/5 of the black-white earnings gap can actually be explained by the differences in the counties in which low-income blacks versus whites live. Put differently, you saw the difference between DuPage and Cook County. We think that if your kid grew up in Cook County, they'd have a lower income than if they grew up in DuPage County. You can use that back of the envelope to say, well, look, there's more African Americans in Cook County than DuPage County. Let's use that as a back of the envelope to understand how much of the black-white earnings gap can you explain with the differences in county level causal effects. It's about 1/5. So just looking at the differences in counties where people are living, you can explain 1/5 of the black-white earnings gap. My guess is that if you go to finer geographies, you could even start to explain even more, because we know even within Chicago, there's a large degree of racial segregation, and we tend to think that that's correlated with what those places might be doing. All right. Okay, so the discussion on policy. So what does this actually mean? Place matters. So if you believe anything today, hopefully I've at least convinced you that where your kids grow up or where you grow up took part in shaping your outcomes in adulthood. But that is still a complicated thing from a policy standpoint. It's not immediate what the implications are. Broadly, there's two types of policies you can think of. You can try to fix places, or you can change the allocation of people to places. So those are place-based and choice-based. We're going to walk you through a couple of different estimates of these policies that actually happen. But there's a large debate kind of in terms of what are the right ways to think about this, and I think it's largely unresolved. But I think what's clear is that place matters, and so it suggests that there might be a role for thinking about using place in terms of policy. Okay, so place-based policy. So this is probably where we have the least solid empirical evidence in terms of understanding impacts. So what can you do to a place to increase its causal effect on kids? Why is that hard? Because the level of randomization, the level of exogeneity has to be at the place level. You need one place to do something, another place to do something different, and you need the reasons they did that to be orthogonal to the kids' potential outcomes. That's tough. And so one nice example where you actually kind of get this is the Harlem Children's Zone. So this is a paper by Dobby and Fryer where they use this expansion of the Harlem Children's Zone over time to estimate the causal effect on kids' incomes, and they use a couple of different approaches. So there's kids that are lotteried into the Harlem Children's Zone. And then there's also these distance instruments, or how far away are you from the Harlem Children's Zone. And so here's this kind of differences in these expansions. So in phase one, they kind of started with this zone, and they kind of expanded out and built these promise academies, and then went up to phase three up in the northern part of Harlem. And I'm not going to go into all of the details that they have in the paper here, but just to show you kind of what they find with both the lottery and the distance strategy. They find that these middle schools are increasing kids' test scores and decreasing absences and things like that. There's a kind of large impact that they find on the test scores. Just to summarize what they find, there's sort of the winning the lottery to enter the Harlem Children's Zone basically dramatically alters their test scores. You get about half of the gap in the black-white test score gap is closed if you get into a Harlem Children's Zone middle school. Now, they also try to decompose this question, which I think is one of the more difficult questions, which is how much is school versus how much is neighborhood? That's a really, really tough question. It relates to a large literature talking about busing and the role of, to what extent can you deal with potential negative effects of segregation through busing and things like that. So what they show in their paper is that the effects of going to a Promise Academy is similar if you are inside the Harlem Children's Zone boundary versus outside the Harlem Children's Zone boundary. And a model with decreasing returns to inputs that it suggests that it's mainly the school, not the neighborhood, that is driving the effects. If you don't believe the model of decreasing inputs, then there could still be an orthogonal neighborhood component that is driving these patterns. But that's an argument that they make in that paper, and I think there's an ongoing debate that I think is still largely unsolved, which is to what extent, A, is it neighborhood versus school, and B, what is the right kind of lever to push on those two dimensions. I think this is just an area that is just completely open for new research if you can find an exogenous policy change at a local place level that leads to kind of potential differences in kids' outcomes. Go pursue it, and let's see what you find. Okay, so second type of policy, choice-based policy. I'll give you an example from the Moving to Opportunity experiment, which is something that we've studied. I'll also show you some work from Eric Chin on the Hope 6 demolitions. So, sorry, I just framed the Hope 6 demolitions as a choice-based policy. I don't know if that was accurate, but it's a moving policy that speaks to choice-based policy. So Hope 6 was actually a policy where they destroyed a bunch of public housing and forced people to move. But okay, moving to opportunity. Moving to opportunity is this policy that was instituted over 1994 to 1996 by the Department of Housing and Urban Development. It involved 4,600 families at 5 different sites: Baltimore, Boston, here in Chicago, LA, and New York. And what it did is it randomly assigned families to one of 3 groups. So it was largely motivated by this Gautreaux housing experiment that I was pointing to before, where families were moving from Cook County out into the suburbs like DuPage County, and they saw large positive impacts on these families. And so what they wanted to do, though, is actually do this in a randomized way and try to actually get some empirical evidence that, wow, it really is the neighborhoods that are driving these causal effects. And so they randomly assigned people to these 3 different groups. An experimental group that got a housing voucher, so a Section 8 housing voucher. So you're currently in a high poverty public housing building. You get the voucher, but you have to move. In order to use the voucher, you have to move to a low poverty census tract. Right? Second group got a conventional Section 8 voucher. They got to move wherever. They didn't have to move to a lower poverty census tract. And then in a control group that got that didn't get a voucher, they continued to live in the public housing. About 48% of eligible households in the experimental voucher group complied and took up the voucher. The remainder did not. They didn't do what's called lease up. So one of the things that's kind of common with these Section 8 vouchers is that not everybody that gets a Section 8 voucher is actually able to find a place in the time allotted to them to do it, which is another kind of puzzle, because these Section 8 vouchers are basically an income stream equal to the size of their current income stream, yet only half of the people are actually able to take up these vouchers. Suggests that these people are facing pretty significant constraints when trying to find housing. All right. Give you a sense of visually where people moved. Here's just a kind of loose example from New York. So the control group were in these towers, the King Towers in Harlem. and they got vouchers to kind of move out. And the experimental group tended to go to places that were a little bit further away, like Wakefield and the Bronx. The Section 8 people that just got the traditional Section 8 vouchers tended to stay a little bit more close by and didn't move quite as far. And so loosely, we're going to be comparing these kind of three different groups to see what happened. So I'm going to talk you through kind of the work we did with the moving to opportunity experiment. This was coming in after a large set of studies that have explored the moving to opportunity experiment over the past 20 years. And basically, the consensus of the literature is that there was some minimal impacts of MTO on kind of adult health, like mental health outcomes, but no economic impacts on either the adults or the teenagers that they were able to measure at the time of the experiment. Just didn't see much in terms of effects. But if you think that place matters in proportion to exposure time for the kids, kind of up to that age 23, then you might expect that the youngest kids are the ones that would benefit the most from these types of moves, right? And so what we did is went back to the data, and now, just recently, they're kind of old enough where, this thing happened in 94 to 98, where those kids are now old enough where they're just entering the labor market. And so we linked them back up to the tax data to look at kind of their income and other outcomes today. And so this is taking a look at this data. So we link them up to the tax returns, and we're going to split these people out. So in previous work, kids who were at this time age 13 and older had already been analyzed. It's the young kids that we couldn't see income outcomes for, and so we're going to split those two groups up and focus kind of primarily on the young kids at the time their families got these vouchers. And so the average age for the young kids, you should think of these kids as moving at about age 8. For the old kids, they're moving around age 15. All right? And so that means that the younger kids had about 7 more years of exposure to a low poverty neighborhood. Okay, so what are we going to do? We're going to estimate these, just use the lottery, the fact that there was random assignment to different groups, and estimate the outcome on an indicator for being in the experimental group or the Section 8 group. And the variation in the probability of being assigned to these different groups varied across those 5 different cities. And so we want to include indicators for those 5 different cities to account for the differential variation in the assignment to treatment. Regress this on treatment, and then that'll get us the intention to treat. So if you were assigned to the experimental group, what's the impact on earnings? We want to scale this up to try to understand what's the impact of a voucher on earnings. We'll do that by just scaling by the 48% of kids that actually took up the voucher to scale it up to a treatment on the treated number, so to speak. Okay, so let me first just show you the first stage. So what did MTO do to the exposure to poverty that these kids had? And so just to show you the difference by each of the different groups. So this is the experimental voucher group. This is the Section 8 group. This is the control group. What you can see is that for kids that are below age 13, at the time their families were given this opportunity to move out, the mean exposure to the poverty rate, so if you just take the poverty rate that a kid is exposed to in every year of their childhood, and you do that separately for different groups, you see that the exposure to poverty rate falls pretty dramatically for the experimental group, a little bit for the Section 8 group, and not as all relative to a control group. And so then you can scale that up by a treatment on the treated and see kind of the impact that the voucher has on exposure to poverty. So all this is to say is that this voucher just had as a first stage. It causes kids to end up growing up in a neighborhood that has lower poverty. Right? So what does it do to outcomes? So this is age 13. And similar things happen for kids aged age 13 to 18. So now what do we do for outcomes? Well, we can go get the outcomes from the tax data, summing up W-2 incomes and things of that nature. So we'll start with W-2 plus self-employment income. Again, remember, not everybody has to file, and especially amongst this low-income population, as you'll see, the incomes are quite low. The filing rates are also a little lower for these groups as well. And then we're going to measure this in years when the income is, when kids are 24 and above. All right, so here's the impacts we see on earnings. So what you can see here is on the left is the intention to treat. You see that income in the control group is about $11,000. So these kids are poor, right? But they have significantly higher earnings if they got that experimental voucher where they had to move to a better neighborhood. And then if you scale it by the by the take-up rates, you can see it's about a $3,000 increase in earnings, which is about a 25 to 35% increase in kids' earnings. And so pretty significant in terms of percentage increases in kids' earnings. You also see that it's increasing over time. So this is showing you the differences in the treatment versus control, experimental versus control in the income estimates as you estimate this at different years, different ages for the child. So you can see that it's kind of growing. So the kids that got the experimental voucher have both higher levels of income, but also are on different growth paths. Right? Now you can also now compare this to what happens, before I get there. In addition to income, so we don't want to just focus on income, we can also look at college attendance. You see the kids are more likely to attend college, so the rate of college going increases from 16.5% to 19%, and it's significant at the 1% level. They also go to colleges that tend to have, on average, higher earnings, so that's this kind of college quality measure, which is maybe a bit too normative, but it's just the average earnings of people in that college. So you can see that increases as well. You also see some other interesting outcomes in tax data. So you can see the zip code poverty share. If you merge up the zip codes of where these kids are living now, you see that they're living in lower poverty neighborhoods. So there's kind of an intergenerational change in neighborhood exposure. And there's also a decrease in out-of-wedlock births as proxied by births where the father is not present on the birth certificate. So this is sort of a way in which, there's not a whole lot of, the tax data is somewhat limited in what it has, but it does happen to have information from birth certificates on whether or not the father is listed. And so what you see here is that relative to the control group, the father is, if the event of having a birth where the father is not listed goes down. Okay, so that's the kids that were young at the time their parents got the voucher. How about the kids that were old, who get less exposure to that place? Here we're not going to see as much. If anything, we're actually going to see a slight decline in individual earnings. Right? It's noisy, but it's not very big. And if you do the estimates separately by age, you just see pretty much not much of an effect here. So this was the old pattern I showed you where people are on a different growth path. This is what happens to the older kids. You also see, if anything, a slight reduction in college attendance, reduction in college quality. And you see no change in where they're living today or on whether or not they have a birth without the father on the birth certificate. And so at the end of the day, what is this? Yeah?
How come you said the age at 13? I mean, you said...
Yeah, so in the paper you do a different cuts, so you probably want something like, let's see, too much heterogeneity here. Do I have the graph? Nope. Okay. So you can do it separately by each age. So the reason we do two groups is because it's just too noisy. So we've gone from having 4 million observations to 4,000. And if you try to do the graph, like the hockey stick type graph, we have it in the paper, but the standard errors are a joke. And so it's just easier to split it into two. If you put a linear interaction with age, you get a pretty strong interaction coefficient with a t-stat above 3. That's actually the strongest kind of t-stat you can get out of the data. But just the splitting by 2 is easier.
Okay, so you try to vary the cut? I mean,
Yeah, absolutely.
To see what happens because...
Yep, so the paper has variation in the cutoff. I mean, you can't reject that it's, once you play with the population data and then you come into this data, it's sort of disheartening because, yeah, I mean, things kind of move around, but they don't move around in a significant way, and so you can't really tell, like, is there anything special about 13? Absolutely not. It's all consistent with a linear exposure effect, except for, if anything, these kind of negative effects that you start to see for the older kids. And so just to give you the intuition that we have from talking with sociologists about that studied this, sort of what might be going on in terms of these negative effects that you kind of see on the older kids. So MTO gave families these vouchers. Anecdotally, the teenagers very thrilled that their parents wanted to move while they were in high school, and so it's not always clear that that the kids actually always went with the parents, and in some cases kind of hung out still in the housing projects, but now without parental supervision. So that's one story for why you actually might have seen a negative causal effect on some of these things. Yeah.
I have a question that is related to your last answer.
Yeah.
I'm curious about the type of exposure to quality. In other words, I really want to know what happens once how the industry actually gets. So this is why I'm always now I'm exploring music. What if no one wants to say hello to me? I'm grocery store. If no one wants to play with my kids, and I guess that's why there's so much noise in the data.
So that could potentially drive, so if you thought that, suppose you think that there's an exposure model where the teenagers have had this exposure to a high poverty environment all the way up to their teenage years, and that makes them potentially less amenable to a higher income environment that doesn't have those same kind of levels of exposure or types of exposure for the kids in that destination. That could potentially explain, some of these differences in patterns. I think, what we can say at the end of the day is not so much about why those kind of patterns are operating. They have anecdotes, that's about it. But that for the younger kids, it looks like they actually do have strong positive effects, right? And so even though you see some negative effects on the older kids, there's pretty significant positive effects on the younger kids. So if there is any kind of difficulty in the kind of degree to which there's mixing, it doesn't seem to happen for the young kids, but maybe it's going on or maybe it's going on for all of them, but just overwhelmed by these other things.
Were there any follow-up interviews or surveys, parents?
Yeah, so there's a lot of good qualitative work. So Zav Briggs would be a good person to look. He's got a great book on this, and also Stephanie DeLuca and others have done some interview work on this. So it'd be good stuff to take a look at. Okay, so let's see. Where did I put the? Here we go. Thank you. All right, so that's MTO. So there's a lot of, in the interest of time, I can show you a little bit. So you can split this out by males and females. You don't see pretty different effects. You can split this out by race, and things are kind of tough to really parse out. Again, you're kind of dealing with smaller sample sizes. You can do this across sites, and you kind of just get a bunch of positive but noisy estimates. Now, one of the kind of concerns from a methodological standpoint that we faced on this work that I think comes up a lot in applied work, especially with randomized controlled trials, is the problem of multiple comparisons. Right? So concretely, what did we do? We went back to a data set that had been analyzed before, linked it up to a new data set, took another dimension of heterogeneity, the kid's age at the time their parents got the voucher, and said, oh, in this subset, we've got a positive effect. Young kids did better. They had a 30% increase in earnings, a 3.5% increase in college attendance. One reaction to that is like, great, you ran enough regressions. Right? You just ran enough regressions that you finally found an effect. Whoop-de-doo. Right? So you want to have a sense of, why weren't we too worried on this front? Well, we went back to the data after we'd done the other work, so we kind of knew in some sense what we were looking for. We were looking for this age, we were looking for the young kids. But that's something we know that, I could just be kind of blowing smoke at you, right? Maybe we didn't really know that. And, would we be here showing you these results had we not found the positive effect? You got to worry about these multiple comparison tests. So in the paper, we do a couple of different things. The concerns are basically that people have analyzed a bunch of different subgroups. So age categories, site heterogeneity, racial heterogeneity, and tried to look for significant effects in all these different subgroups. What you would worry about is that if you splice it enough times, in some of those subgroups, you're going to get a positive effect. So you can ask, given the number of times this thing has been divided, did we find something that is really kind of significant in the kind of frequentist sense that we should be surprised that we found this? How unlikely would it be that we actually, returning to this data, found this effect? So we do two approaches. The first is a parametric F-test, and the second is a non-parametric permutation test. And I think these are kind of just useful to talk through because I think they come up a lot in your own, in a lot of what will be your work in the future, or maybe in your work in the past. So the first way to deal with this is just imagine that you have a whole bunch of indicators for different groups in the data. So take age, site, gender, and race. You've got a whole bunch of different interactions of those groups. And in each of them, you can do treatment versus control. So you imagine your regression where you've got a whole bunch of interactions with all of these different treatment indicators. And so how do you test for multiple comparisons? Well, you can say, do any of these have a significant effect? So that's an F-test. So you just test in Stata. That's just literally test if all those coefficients are 0. Stata is going to give you an F-test. It's going to test that, and this is just showing you for different ranges of outcomes what those F-tests are. And so that's one way of doing this. The F-tests require a parametric kind of assumption on the distributions of normality and can sometimes not have great finite sample properties. And so people tend to not like them as much recently. And another reason that you might not want to do F-tests is that there's basically a kind of almost strictly dominated test, which is the following permutation test. So when you have an experiment that randomly assigns people to treatment and control, you have a finite sample exact approximation to what your sampling distribution is under the null. Why is that? Well, what's my null hypothesis? My null hypothesis is that treatment doesn't matter. That's my null hypothesis. So under the null hypothesis, I can randomly assign treatment in the data set. So to heck with the treatment variable I have, I can just generate a random number. And what should happen is I should get, the question is, does this distribution of p-values that I get from that procedure generate something that looks like a p-value I get in my actual data? Okay? So what we're going to do is we're going to randomly reassign treatment and ask how crazy does the actual p-value that I get look in the distribution of p-values you get from that process. And what's nice about doing this process is that you don't really know exactly, you don't need to know kind of the sampling distribution or whatever is generating that p-value. You can just simulate it from your actual data. So this is showing you for each of the different subgroups what the actual p-value is on all of our different estimates. So we see the age under 13 one is the thing we went back to the data looking at. But you also have all these other different subgroups that you could have expected finding a p-value. And what we did, imagine now simulating us horrible researchers who are just p-hacking. What would we be doing? Well, we would be taking the minimum p-value here, and we're coming to you and saying, hey, we found an effect on these young kids. And so what does that mean? It means the minimum p-value is 0.014, right? So now you can imagine, suppose you actually were doing that. Suppose I was just p-hacking, right? And suppose treatment was randomly assigned. I can generate just placebos, right, from randomly assigned treatment. Each one is going to give me a p-value across all these different groups, and you can simulate the distribution of the minimum p-values that you get from this process, right? Now I've got my true p-value and I've got a distribution of p-values. Where in the distribution does my minimum p-value fall? That gives you an adjusted p-value that is sort of finite sample exact approximation, finite sample exact for this kind of p-hacking procedure, right? And so you can say that my adjusted p-value, well, geez, only 1 in 10 times in this hypothetical example do I get a p-value that is below that 0.014. And so that's an adjusted p-value of how surprised should you be that I found this? Well, 1 in 10. Okay? So we actually do this. This isn't the real data that I just showed you. If you actually do this, we get p-values below 0.01 using 1,000 replications. And so you can reject the null at pretty standard levels of significance. Okay. But these permutation tests are really growing, I think, in cases where you have binary treatment assignment that's random. I love them. I think it gets around a lot of other problems, like people worry about like clustering standard errors. All that stuff goes out the window. You don't have to worry about kind of correlation structures. You're just thinking about your treatment assignment, and it's very, very clean. So, all right. That's my plug for the permutation tests. Okay, quick comment on treatment effects on adults. So we actually replicate a lot of the findings in earlier work that there's not much impact on adults. So we return to the tax data and now look at the adults. So adults do get more exposure to better neighborhoods. They live in lower poverty neighborhoods. But if you look at their earnings as a function of how long they spend in that better neighborhood, they just don't change. The difference between treatment and control is basically zero for all kinds of years relative to when they get assigned. And so this is actually rejecting the kind of pure Kane or Wilson spatial mismatch theory that kind of adult earning differences are driven by access to jobs or in the local neighborhoods, right? We think that actually these moves generated kind of exposure to, generated moves to better neighborhoods as measured by local poverty rates or other measures of kind of local amenities in terms of job availability. But we don't think it had any positive effects on the adult earnings. There's some evidence it affected mental well-being and that the people who got the vouchers were happier, but there's no evidence of any impact on their earnings. And so this is, I think, consistent with this idea that it's childhood exposure that is really driving a lot of the differences in the outcomes that you see, and not as much differences in exposure once you're above age 23 or so. Not to lose hope now that we're all above, I think everybody in the room's above 23. It's not like, there's no variation in what happens, but in terms of explaining geographic variation in kind of degrees of upward mobility and poverty, it doesn't seem to be as strong. Okay. Oh, here we go. I did have this. So this was the kid one I was referring to before. So this is trying to replicate our hockey stick pattern in the MTO data. So this is what happens when you go from 4 million to 4,000 observations. You lose a whole lot of persistence, or a whole lot of precision. But you do see a downward sloping pattern, which is nice. Yeah.
You mentioned that take-up was higher for families with younger children, right?
Yes.
So do you think parents
take-up rate?
understand the exposure effect in this context? Do you think they anticipate that?
Yeah, I think they know that they shouldn't take their teenagers out of high school. That's honestly the model I have in my mind. The other thing I was going to show you, if I go back, yeah. So here's the take-up rates: 48% for young kids, 40% for older kids. Similar pattern for Section 8 if you don't have anything. The other thing you see is that the experimental has lower take-up than the Section 8. In other words, a lot of families, if you restrict them to have to use it in a kind of lower poverty census tract, that decreases the take-up rates. But I think there could absolutely be, to the extent to which we think that the older kids, didn't benefit as much, the differential take-up could be reflecting this trade-off. Absolutely. Yeah, Trevor.
How does this compare to ordinary Section 8 take-up in other periods?
Oh, it's very similar. So we're working with the Seattle Housing Authorities. Their take-up rates are in that kind of 60% range. Yeah, a lot of people leave vouchers on the table. Even in Cambridge, where I'm from, it's like 60%. I think it's kind of crazy to think of the amount of income that's left on the table by these families.
And just one clarification, because it looks like you're about to go to the chin research.
I think so. We'll see what's next. I'm surprised myself sometimes.
Yeah. What kind of selection was going on into MTO? So of course you don't get to determine what arm you're in, whether control or between two treatments. But we were talking yesterday morning about the chin thing briefly, and it sounds, because there's some difference, I think one of his advisors was presenting to us. This came up, and there was the implicit contrast with that paper is not going to find the negative effect.
You talk about the reverse Roy sorting that was in the original version of Chin's paper. So Chin's paper has now been revised to fix that. So, yeah. So I have strong. So now we're inside baseball on disagreements I have with this paper. So basically, Chin's paper that I'll show you in a second is going to find positive effects on teenagers, and is going to find positive effects on younger kids even more so than teenagers. And part of the question then is sort of why might there be. So he finds positive effects on teenagers and young kids, but then does Section 8 lotteries and shows that there's a, let me step back. There's another way to get at the impact of Section 8, which is to exploit the lottery aspect of it. So Section 8 vouchers are not a right. It's a voucher that you're given if you get off a wait list in most cases, and it's often random whether or not you get off the wait list. And so people have done a lot of great work. So here in Chicago, Jacob Ludwig and so Brian Jacob and Jens Ludwig have done a lot of work looking at the impact of these vouchers on kids. And the broad consensus is that basically there's nothing. If you get a Section 8 voucher in Chicago, it basically has minimal impacts on your kids. And so why is that? 80% of Section 8 housing vouchers are used in high poverty neighborhoods. And in fact, best evidence I've seen is actually that when your parents get a Section 8 voucher, they don't improve neighborhood quality at all. If anything, they might pick better unit quality. So this is related to some great work that Stephanie DeLuca at Johns Hopkins has done, showing kind of how people choose kind of neighborhoods versus places. And that low-income families tend to focus on the characteristics of the unit because they tended to grow up in places where the neighborhood wasn't something you would kind of want to experience necessarily, but the inside of your house is something that is very salient and nice. So you get a Section 8 voucher, it goes a much longer way and maybe a worse neighborhood, which then leads to getting a Section 8 voucher not actually improving the childhood environment for kids. And so in the original version of the Chin paper, there's the following comparison. The Section 8 voucher getting a Section 8 voucher has no positive effect. So when you give people a choice of moving to a better neighborhood, it has no positive effect. When you force people to move to a better neighborhood, as I'll show you in a second, it's going to have a positive effect on kids. And so the potential interpretation is that kind of the set of people who are choosing to move are actually the ones who are benefiting the kind of the least from the actual movement. The reason I disagree with that interpretation is that the treatment is different, right? Because in the experiment I'm going to walk you through in Hope 6, they destroy the neighborhood. They tear down your building. You're forced to move. And so you change neighborhood environment, and they tore down the worst possible housing projects they could. And so on average, your neighborhood improvement is going to increase. You're going to get a better neighborhood out of this. Whereas with the Section 8 lottery, you're not going to change neighborhood quality. It's exactly the logic we were just showing through. In practice, you don't see that. And so it's not necessarily that there's a kind of sorting on the causal effect. I think it's going to become fashionable to talk a lot about kind of what's the correlation of sorting versus with the kind of, are you sorting on the levels versus the kind of causal size of the causal effect. And I don't want to disagree with that potentially being a story, but I think it's not what's going on at all in terms of explaining the differences between the Section 8 and the Hope 6.
And to the question though, compounding the difference, not only are you potentially changing the neighborhood in a very different way than MTO, but there's no real ability for these folks to avoid them. Whereas people didn't have to enter the Section 8 lottery that would have led them into MTO.
That's right. So I mean, the Hope 6 is also just a different treatment in general, but I think it's also, the fact that you can document that Hope 6 leads to different neighborhood changes than does Section 8 vouchers suggests if you think neighborhoods are what the unit of treatment is, that it's a different experiment from that perspective. Yeah. So we just did a lot of work talking about the Chin paper without talking about the Chin paper, but hey, why not? So here we go. That was a good introduction to the Chin paper. Okay, this is a great paper, honestly. This is, I think, this is really good work linking up these Hope 6 demolitions that occurred here in Chicago to administrative data here in Chicago and looking at the long run outcomes. And it builds on some earlier work by Brian Jacob there and many others. And so what we can do is look at the density of neighborhood poverty for displaced and non-displaced households. And so what you see is if you basically were kicked out of these, if your public housing project got destroyed, so you want to think of, if anybody who goes to the baseball game tonight, take a look before you go at the, oh my goodness, why am I blanking? Who knows the name of the public housing projects you're going to pass just up by Comiskey? Oh my goodness, this is embarrassing and it's on video too. I'm no longer reputable. Okay, so once my mind stops blanking on this, there's a public housing class, Caprini Green. You're going to pass public housing projects on your way, what were housing projects on your way up there. And I think those were destroyed, and if I recall, they were destroyed under Hope 6 when those families were then given vouchers to move to different areas. And so the variation that he's going to live off of is that if you were in one building that was destroyed versus another building that wasn't destroyed, what's the difference in the outcomes in the kids later on? And this is showing you the differences in the poverty exposure that the kids get. This is showing you how it varies years since demolition, and this is then showing you the impact on earnings. And so what you can see here is that there's positive impacts on kids' earnings throughout the distribution. A little bit higher once you get a little bit older. That's employment. and this is annual earnings. So what I like about this one is that you start to see annual earnings increase pretty significantly after age 28, which is pretty consistent with what we saw in the MTO experiment. You know, if you remember that kind of increasing trajectory pattern, that was starting at about 26, going up to 33 or 34. And so you can see that you start to see, again, this kind of similar trajectory, that the earnings differences from these neighborhood exposures pop out in late 20s, early 30s. Now you can also split this out for young versus old kids. And what's different with the Chin paper relative to what we saw with MTO is that he's actually seeing positive effects on both subsets of kids. And so he doesn't see these kind of negative disruption effects. There's two interpretations for this. So on the one hand, you might think that just it was a different experiment of blowing up that. So suppose what was my explanation for the disruption effect of MTO? It's that the teenagers, basically their parents move to the suburbs, teenagers are upset, they go home on the weekends and get into trouble with their friends. Okay, that's basically the story. Now, I get to tell that story because I have no evidence for it, and it's easier to tell stories when you don't have evidence to reject it, but that's at least one anecdote for what's going on. Suppose that's what you think is going on. Obviously, you can't go back if everybody in your place was kicked out, which is exactly what happened in the Hope 6 example. Yeah?
Well, I'm not familiar enough with Hope 6. How much time was it between the destruction of each building?
Yeah, this is an interesting thing. So there was enough time for him to get the variation. I'm trying to remember the exact length of time. In years, but yeah. Yes, years. And so another explanation for the difference is that there's negative impacts of having your neighbor's house destroyed. Having so this is basically saying it's a positive effect if you were in a building that was destroyed. You remember we're treatment versus control here, so it could also be a negative impact on the people that are left behind. So that's a potential threat to identification of this strategy that he does some work in the paper to argue is not the case. But yeah, I should know the difference in the years on those, and I don't off the top of my head. Okay, more earnings graphs, okay. So where do we end up on this? Place matters. That's sort of the high-level thing that I wanted to try to argue. Place seems to matter in proportion to exposure time. Every year seems to drive of exposure to a better place, seems to drive good outcomes in adulthood. Open questions. So why? I think that's the biggest open question. Why does place matter? I can give you, some correlates of good places and bad places, but pretty unsatisfactory, right? Don't have a huge good explanation for this. And then, it relates to this kind of question of choice versus place-based policies that require estimates of these kind of other causal effects that we don't know the answer to. And it also opens up the question of kind of cost effectiveness. So even though this suggests a potential choice versus place-based policy, you could imagine that there's models we could write down of optimal taxation where even if place matters, doesn't mean you should subsidize it or tax it or do anything about place. You could still do everything through the income tax schedule. And so thinking about how does place actually integrate into kind of a model of optimal taxation is something that I think is largely unexplored and potentially interesting. And a lot of those inputs into those questions have to deal with its cost effectiveness. So is place-based policy a more efficient method of redistribution per se relative to other methods like the earned income tax credit? I can give you a Section 8 voucher, or I can give you an earned income tax credit. You might like to know the answer for every dollar the government spends on each, which does better. And so that's sort of a crude kind of way of looking at it, but at the end of the day, it's not a terrible first pass, I think. And one of the key things to put as an input into that is to think about kind of fiscal externalities of these types of policies. And so one of the things we looked at in MTO is what happens to future federal tax revenue from the kids who get the Section 8 voucher. And so what you can see is today, kids who are in families kids who were less than 13 at the time their families got these vouchers, today are paying $400 a year more in income taxes. And that's persisting throughout over time and actually growing to the point where this difference in between experiment and control actually can cover the cost of the voucher. And so now you're kind of in a world where geez, maybe some of these neighborhoods have gotten so bad. There's a win-win for helping people get out. But the flip side is, maybe there are kind of competing stories about the impacts on the places where these people went or on the people left behind. MTO was actually supposed to be a kind of long multi-year policy. But after the first year, residents in the destination locations protested and it was shut down. So it was intended to be a longer run set of interventions, but it never materialized. So that is the majority of what I wanted to cover. I have an additional about half hour of slides on time trends in mobility that I'm happy to cover. Since we only have 5 minutes, maybe what I'll do, are people interested in seeing, so loosely related stuff on sort of thinking about how mobility has changed in the US over time? Is that interesting to talk through briefly? Okay, so we'll talk through that for a few minutes and then maybe we'll call it for lunch. I am the man who stands between you and lunch. Sorry. All right. You never want to be the speaker that goes right before lunch. Right after lunch is worse, though, I guess, because then everybody's asleep. All right. So how has mobility changed over time? So I threw in some slides here at the end that are kind of fun because it's some work that we put together recently trying to measure rates of a different measure of mobility. It relates to this kind of stuff we were talking about, relative mobility or kind of absolute mobility, and kind of how do you think about measuring these different things. And the motivation for this is that we felt like we were measuring mobility perhaps in the wrong way. Often when you ask people, is the US an upwardly mobile place, they think about it in terms of, do I earn more than my parents? And that's a different statistic than everything we were just talking about up to this point, right? Everything we were talking about now is sort of what is your level of income for a low-income kid? But we were ranking parents relative to other parents, and we were ranking kids relative to other kids. We weren't comparing the distribution of kids' income to the distribution of parents' income. In fact, any monotonic transformation to the kids' income distribution and the parents' income distribution would leave all of the estimates in ranks, at least, that I showed you unchanged. In dollars and percentage terms, it would be different, but in ranks, at least, they'd be pretty similar. And so we wanted to go after this other measure of mobility. And so why aren't there's actually not much work looking at intergenerational mobility in incomes over time. And the main reason is because there's not a large administrative data set or really even panel data, any kind of panel data set that goes back very far in time that allows you to link parents and kids. So the PSID is probably the perfect data set starting in 1968, but it doesn't go back to maybe the 1940s or where you want to go, and it also doesn't have very large enough samples that would allow you to kind of estimate, say, a 1968 cohort effect. In fact, if you pool the 1968 to the 1990 cohorts, you can start to tease out maybe a little bit of a pattern, but it's pretty tough. And so what we did is we split this into 3 components, and I'm just going to try to skip this and think about the following. So how are we going to try to estimate this? We're going to think about estimating the fraction of kids, and we're going to go back to 1940 using this method. We're going to estimate the fraction of kids earning more than their parents by asking whether or not a given level of the income distribution for kids is above the income distribution for parents, and then multiply that by the copula, the distribution of parent and kid ranks. And so what this is going to allow us to do is use data from the marginal income distribution of kids, the marginal income distribution of parents, and the joint distribution of the ranks of kids and parents. So why is this useful? We have some evidence, at least in the last 20 years, that the joint distribution of kid and parent ranks, so think of that kind of first graph I showed you for Chicago, but aggregate up to national, that slope looks to actually be pretty stable across cohorts. And so if you think that that graph is stable across cohorts, but we know the income distributions are changing pretty dramatically across cohorts, then you can use the estimates of the income distributions, just the marginal income distributions, to understand something about rates of absolute mobility, the fraction of kids earning more than their parents. And the way to think about this is if I know the marginal income distribution of kids, I know the marginal income distribution of parents, then I can say, okay, if I know for each given rank of the income distribution what fraction of kids are above or below that threshold, then I can compute what fraction of kids are earning more than their parents. And so the basic strategy is going to be to estimate these kid marginal distributions, the parent marginal distributions going back in time using census data back to 1940. And we're going to combine that with an estimate of the copula, the joint distribution of ranks, from recent times. And then do some robustness analysis to say, suppose the copula did change. So what you're going to be worried about is that you're not going to see the copula, the joint distribution of kid and parent ranks, from 1940. And so what we can do is, I'm going to show you some robustness. It turns out that the distribution of parent and kid incomes are going to be such that it's not going to matter what the copula is. So let me give you that intuition here in a second. Okay, so I'm going to skip the fun details and get to the fun. So this is showing you for the 1940 cohort what fraction of kids earn more than their parents. And what you can see is for kids that are at the bottom of the income distribution, almost everybody grew up to earn more than their parents. That's also true even for kids near the top of the income distribution. About 90% of kids whose parents were at the 80th percentile grew up to earn more than their parents. As you go through the decades, you start to see this fall to the point where in 1980, we see that if you were born at the 50th percentile of the parent income distribution, only about 45% of those kids grow up to earn more than their parents. And so you can now plot this just separately by cohort, pooling across all parental income levels. And you can see that on average, about 90% of kids from the 1940 cohort grew up to earn more than their parents. Today, it's about 50-50. Right? And so why is this driving the difference? Well, so let me show you, before I get to why, let me just show you the robustness. So what's the key assumption? We assumed that the copula that we know from tax data today, so that blue line for Chicago basically applied to this data, we know that's pretty stable going back in time. Or sorry, we know that's stable in recent years, but we don't know it's stable going back in time. Right? So what we can do is actually a linear program that searches over all possible copulas to ask what's the range of potential mobility rates that we would see in the data. And it turns out you actually get a pretty tight bound on rates of upward mobility back in the 1940s. And so why is this? If you show let's see if I have it. Yeah, here we go. This is the distribution of parent and kid incomes from 1940. And what you can see is that kids were almost uniformly earning more than parents. So this is kids 30 years later are almost uniformly earning more than their parents. So if you look at the 80th percentile of the parents' distribution, that's like the 14th percentile of the kids' distribution. Right? So basically what this means is when you search over copulas, there's only so many ways you can put parents' mass above kids' mass. And so it bounds that at least 80% of kids are earning more than their parents. And that's just a linear program you can write down to compute using these two distributions. Here's the distributions today. And you can see that they're much more on top of each other. And so now, two things. One, the copula sure matters. Like you can certainly put all the mass so you have kids equal parents plus epsilon. And now everybody's doing better, or kids equals parents minus epsilon, and nobody's doing better. So the copula, now you need an estimate of the copula because these distributions are overlapping. But it also is an explanation for why you're seeing such lower rates of upward mobility. Basically, the distributions are the same. The copula is pretty much persistent, but not too systematically crazy. And so you end up with 50% of kids earning more than their parents. So I'm going to skip some of that. Oop, did I kill this thing? Yeah, so you end up with 50% of kids earning more than their parents. And so you can plot these. This is just a graph. I guess I'll walk you through this graph and then we'll call it. So this is the parent income percentile, and this is the kid income percentile. What this graph is showing you is for each parent income percentile, so suppose you were born to a parent at the 50th percentile in 1940, where, relative to your peers, would you have to fall in the distribution of kid incomes in order to earn more than your parents? You only had to reach, say, the 10th percentile of the kid income distribution to beat your parents back in the day. Conversely, in 1980, you got to reach the 55th percentile. So you have to do a lot more work relative to your peers in some sense to beat your parents today than you did in the past. And so in the paper, we go on then to kind of ask, what are the two forces that drive this thing? On the one hand, there's some changes in economic growth. So there's a slowdown in economic growth in the US a little bit, but that's actually only explains about a third of it. The bigger difference is the change in income inequality and the allocation of growth across the income distribution. Today, growth is concentrated more towards the top regions of the income distribution as opposed to the middle, whereas in the past it was much more spread around. And so as a result, another dollar to people at the top of the income distribution just intuitively doesn't do much for changing the fraction of kids earning more than their parents, because kids at the top of the income distribution are already earning more than their parents. And so as a result, it's not just that there's a change in economic growth. It's a small role, but it's not the whole story. About 2/3 of the story is the fact that the way in which economic growth is allocated is such that it doesn't lead to kids earning more than their parents, because kids that are at the top of the income distribution are already earning more than their parents. So that's the crux of that. Okay, so I have now taken 3 minutes out of your lunch, so I'll stop there. But thanks for your time. I'm happy to talk more.